Alright guys, so let's continue with our class number 10th, and we're going to continue with, hopefully you've started your machines there already, and so I'm gonna go ahead and try to go for more topics there. So what we have done last time, last class, we have done virtual standard switch and vMotion, right? So the vMotion was just the migration, and then let's go for more advanced features there for VMware, and that is, let's create a cluster, and inside cluster are many high availability and disaster recovery features. Disaster recovery features, like in the cluster, first of all, cluster collectively calculates the resources of all servers that are inside. So what is cluster? So I'll just put it here. Cluster is a group of servers slash hypervisors. Obviously in our case it's hypervisors, where our cluster collectively calculates the resources, the hardware resources, the underlying hardware resources of all the hosts slash, what is a host? It's a hypervisor. Hypervisor, what we call ESXi, right? So hypervisors. So hardware resources of all the hosts hypervisors. For example, if we have 5 hosts or hypervisors or ESXi hosts with 1 terabyte RAM each, then cluster will see total 5 terabyte RAM available for it. So the example, so the cluster, obviously it's a grouping of servers, and that group of servers are then a collective resource for the cluster. So cluster can decide that if there are virtual machines there, so obviously for that I need to go for a diagram. I'll just grab that one diagram from here. So suppose you have a virtual machine here, and first of all we have 2 hypervisors, right? So these 2 hypervisors will be now connected or grouped together in a cluster, and these hypervisors will be managed by the cluster. So if they had 1 terabyte each RAM, then that would be 2 terabyte RAM total the cluster will report. And why cluster does that? So cluster checks that suppose there is a 16 core processor on ESXi 1 and 16 core processor on ESXi 2, so it will be 32 core total processing that cluster has. It just calculating the total available processing, or total available RAM, or total available SSD or disks or storage that is available in a group of hosts in a cluster, right? So suppose there's a virtual machine here, and that virtual machine, or there is a lot of virtual machines here, and they are obviously all critical virtual machines, suppose, or some of them are critical, and the cluster needs to know that underlying how much these virtual machines are doing, are using how much of RAM, how much of CPU, right? These are the most contested resources. Every virtual machine during the peak hours of you can say 10 to 2 or 10 to 3, 10 a.m. till 3 p.m. right? So the work is at the peak, and the people are really, uploading, downloading files, sharing files with each other. So a lot of pressure on the machines. So there are end users connecting here to this machine. Suppose it's a web server. There are end users connecting to this machine. Suppose this is a SQL server, and this is a print server. So all these machines have a lot of users here. Hey, they look like here, right? If I do this and this and this becomes cool. Okay, just kidding. So yeah, here, not here, like here, here. Anyway, just kidding. So there are so many users connected to this machine. Now, what if this whole physical server goes down, crashes, right? So the cluster needs to already know before the crash, before any possible crash, the cluster needs to already know what? It needs to know if this server goes down, then will the other hypervisor or hypervisors be able to accommodate all the virtual machines of the crashed hypervisor? So the cluster has to do some advanced calculations of its available resources among all the grouped together hypervisors. So it would know that if in case one of the hypervisor goes down, we're talking maybe 5,000 users disconnected or 10,000 users. How 10,000 for one hypervisor? One hypervisor may have 10 virtual machines, suppose, or 5 virtual machines. Each virtual machine is receiving 2,000 connections, or 1,500 connections, or 1,000 connections here, right? So the hypervisor goes down, the virtual machines will be effectively disconnected. There will be a downtime there, and these machines will be restarted on the other hypervisors or physical hosts, right? But suppose the physical host has a lot of already, a physical host here on the other side here. It also has virtual machines, right? It has virtual machines of its own. The first host has virtual machines of its own. They are all working fine until one host actually crashes. So if the one host crashes, not only the other host has to still accommodate its own virtual machines, but the virtual machines of the crashed host as well. So the cluster has to calculate in advance how much of the total RAM I have collectively from the two hypervisors, and how much of the total CPU processing I have collectively. So it will try to put some of the configurations, it will try to implement some of the cluster will try to implement some of the configurations here where the whole environment can afford the loss of at least one hypervisor, right? So this means that the other hypervisor may leave 20% of CPU and RAM, may not use the 20% of CPU and RAM. Why? This is also called capacity reservation, that you're reserving the capacity of CPU and RAM here. So in case whenever the disaster strikes, suppose the disaster does not strike for next 2 years or 5 years, but whenever the physical host actually goes down without warning and the machines had to be restarted, so the other host had some reserved capacity for these machines. If the disaster strikes, did the other host had enough or reserved CPU and reserved RAM or not? If it had reserved some of the CPU and RAM, that in case the first physical host or the second physical host goes down, then in that case the other surviving host, it will accommodate all the virtual machines of the crashed host. So when this host goes down, its virtual machines will be restarted if there is enough CPU and RAM on the other host. So this is one of the jobs of the cluster, to know that, hey, can we afford, if one host goes down, can we afford that disaster? Will we keep the work going if the host goes down? So that's why cluster tries to calculate all the resources and tries to also reserve some of the resources. It tells every hypervisor in the environment, hey hypervisor, we need to reserve some capacity here, because if one of you goes down, then the other must also start or accommodate the virtual machines of the gone down or crashed host. So other hosts should be also able to accommodate all the machines of the crashed host, right? So cluster really does those calculations with the help of a feature called HA. So okay, Manu, hold on. Sure, no problem. And so what we are talking about here is the cluster, and in the cluster actually combines the resources collectively of all the hosts in the cluster, and the cluster is a group of servers there. And what happens is that cluster offers a lot of high availability and disaster recovery resources, and the cluster can do capacity reservation, which is what we're going to know now. Capacity reservation, right? So in the capacity reservation, what happens is enough CPU and RAM is reserved for the VMs that may need to be accommodated may need to be accommodated. So for the VMs that may need to be accommodated on the surviving E6i hosts, right? So every host must not use, suppose, 20% of CPU and RAM, right? Why? If one of the hosts goes down, its virtual machines need to start on the other host, and if the other host has already used up all its CPU and RAM, how can it let the crashed host virtual machines be accommodated if it doesn't even have CPU and RAM available, right? So cluster makes the hosts not use some portion of CPU and RAM in order to accommodate the virtual machines of any one crashed host. So this is also called, cluster can tolerate the loss of one host, which means that it has reserved enough CPU and RAM that at least one crashed host's virtual machines can be accommodated on the rest of the hosts. Suppose we have 2, 3, 10, 20, 200 hosts there. We have just 2 hosts, right? So we were talking about cluster, and we need to create a cluster in our environment, and then we're going to go ahead with the high availability HA, and then DRS, which is distributed resource scheduler. So those are the features that are lined up, and obviously in your interview they will be very interested to know if you know these concepts. So HA is high availability. We're going to talk about that now, and then obviously without I'm saying DR, it's DRS. So without DRS, or distributed resource scheduler, without DRS, obviously, so they normally work together, HA and DRS, but there's a big difference between them too. So we're going to talk about that. And then fault tolerance, another very, very critical feature of cluster. There is enhanced vMotion compatibility. We're going to talk about that and do some comparisons. And then affinity rules, which is already not an abbreviation. And then we're going to go for virtual SAN. So that's going to be, this is also a very critical feature. So these are all very important features, and then we will go ahead with other features like backup and patching and other features. Okay, so what about then this HA? What is HA? What is DRS? And what is FD? First, instead of going only for HA first, a good approach would be to know these services because of the comparisons, right? So in order to know these services, we need to compare them, and I'll just then explain when we use high availability, when we use DRS, distributed resource scheduler, and then when we use FT, which is fault tolerance. So without understanding that, obviously it's not going to be that easy to go ahead and understand anything else about these. So and we can understand that by comparing those services. So what happens is, and obviously it's going to come in your exam final term, but the main thing is it's going to come in your interview. That's what you need to be prepared for. As the market outside is tough, you need to pass these exams, and in other colleges people are passing this VCP-DCV certification, which is very critical nowadays. They are really asking a lot of VMware experts, so do repeat all the labs for the job. And maybe you're very busy with other subjects as well, but this is for the job preparation, right? So this is very critical to repeat all the labs and try to upgrade your RAM and CPU whenever you can. Let me know, I can just give you address as well. But the thing is, without good hardware, obviously you cannot practice. So whenever you get time and the budget, try to upgrade your laptop to 32 GB RAM and i7 quad-core CPU. Okay, so Sylvester says in the chat, can we start reading the dumps and prepare for the certification? Yes, it's always a good idea to go ahead with start reading the questions, and there is that question access that I have already offered. You can just join that 1-year program and don't go for just this one certification. Go for Azure AZ-104, go for Azure Administrator, go for the other one, AWS, because there's a lot of competition and everyone's going towards cloud certification, so you must do those as soon as possible. And do the certification. So Russia says that, and do the certification immediately after the exam once we get the voucher. Yes, that would be a very good idea. Start reading now, and as soon as you get the voucher, you should be able to then give the exam, right? So voucher normally is given at the end of the course, so by that time you should be prepared to give the exam. So that's a very good strategy. But this is one of the certifications. Go for AWS as well, very critical. Azure, more jobs are for Azure Cloud and GTA here. And if you can do RHCSA, which is Linux, that's a wow as well. Okay, so we are just trying to compare the three most critical services here, and that is, first is HA, which is high availability. So try to understand that, guys, because in the interview they will ask you that, and you should be very comfortably giving the differences between these certifications. They're not gonna just stick to only this, obviously. So high availability, and that has high availability. So it is used when when a host crashes. So it is used when host. So guys, one more thing about the marks. Suppose at the end of the course, normally students realize that, very few students realize that, but if you haven't uploaded the lab or screenshots today, right, and you haven't given a reason as well, right? So some students have given me a reason, 2 or 3 students only. So, but you haven't given me a reason and also did not upload. So then obviously I can't give you marks. If marks is any important, then you should be in the class and or let me know why you were not able to upload, right? So these are just I have to also, explain to management what happened whenever they ask. Okay, so Zian says here, is host a VM? Well, in our case, yes, but normally host is a physical server. So this E6i1 is a host, E6i2 is a host. We are in the training environment, so yes, it's a virtual machine for us, but host is always a physical machine. Host is always a physical machine, right? In a production environment, in companies, E6i1 would be on HP, Dell, IBM physical server directly installed. And here in training environment, obviously, VMware has provided that software, VMware Workstation. because for the very purpose of training. So host is a physical server. Okay, HA, high availability is used when a host crashes, right? When a host crashes, the VMs, yes, Yang. So cluster would be grouping the physical hosts together. Yes. So cluster would be grouping the physical hosts together. So good question there. And a cluster is a group of servers, hypervisors. I should just add here, hypervisors are always physical hosts in our training environment. It's virtual, but physical. These are physical machines. IE, HP, Dell, IBM, etc. Right? Cisco also have physical machines. So, yeah.
So we have EX1 and EXI2,
Yeah.
right? And so the cluster is for the purpose of one of our EX5 is goes down, so the others can take care of the load from that one.
Yes.
That was what cluster does? Okay.
Exactly. Oh. Okay. So these are all physical machines, the servers, the hypervisors. Basically, we're talking not about servers, and servers could be misled into, maybe Windows Server 2016 or so. This VMware cluster is not for that. Microsoft has its own clustering feature called failover clustering, and this is purely for VMware hypervisors. The cluster is created, and those are installed on physical machines. Now we're going to check it out that how are they different, right? So high availability, it is used when host crashes, and virtual VMs on top of the crashed hosts are effectively, there's an effective downtime, so are shut down. So there's an effective disconnection there. There's a downtime there. So VMs on top of the crashed hosts are shut down and then restarted on another host, right? So that is HA triggers when there is a physical host crash, right? Then HA is used. High availability is used in that time. And what it does, it simply restarts it on the other surviving host, right? So that's the job of HA, or when does HA trigger. So if I ask you that, or in the interview they ask, either in the final exam or in the interview they ask, so you need to know that which service gets triggered at what scenario, right? So DRS is there, and this is distributed resource scheduler, and in this distributed resource scheduler, what happens is that if a physical host is slow, for example, less CPU and or RAM, right? Either less CPU or RAM, or less CPU and RAM as well, less CPU and less RAM as well. So in that case, if a physical host is slow, then DRS simply calculates how much CPU and RAM is available in other hosts, and if there is a host having more CPU and RAM, then it vmotions the VMs to that host. So DRS is good as long as the host is powered on. DRS only works as long as the host is powered on and can do vmotion of VMs, right? So if somebody thinks that if the physical host crashes, right, it shuts down for some reason, then DRS can view motion the machine? So no. When the crash happens, the virtual machines are shut down also, and they are restarted on another host. So when the host goes down, HA triggers. When the host is slow, DRS is triggered, right? When the host is slow, DRS is triggered. When the host crashes, HA is triggered. So we must know the difference here, and you cannot vMotion a virtual machine when the host is crashing. A vMotion can only happen if the host is powered on. It stays powered on, and you can move a virtual machine from one host to another. So DRS kicks in when there is less CPU and memory, and you can just it's your choice. You want DRS to work automatically and aggressively, then you can do that. It will automatically just check that which host has more CPU and RAM and which has less. The virtual machines on the less CPU and RAM host will be moved from there to the host that has more CPU and RAM, right? So this is really important. Then the FT. What is then FT? If HA kicks in when host crashes. DRS kicks in when the host is slow. Okay, there's a question. Do the vMotion? Yes, DRS can. So it's up to you. DRS can do the vMotion automatically, or DRS can suggest or recommend only, hey, please vMotion the machine because that host has less RAM, but there's another host I calculated and that has more RAM. So it's up to us to select the option that DRS can automatically move the machine on our behalf, or the DRS will just suggest to us and we will do the vMotion. So it's I'm going to show you where the options are, but yes, it's up to us that we want the DRS to work automatically or not. So, but it can work automatically as well. It's so automated that even the boss won't need us, and the boss might kick us out even that, hey, DRS is doing everything, then I don't need you, okay, bye-bye. So no, just kidding. But obviously this can happen if you put DRS on fully automated and aggressive mode. That is called automated and aggressive mode. So I'm going to show you where it is and how does it work. So FT, fault tolerance, right? So when does this kicks in? Fault tolerance. So if the VM or host crashes, then FT fails over the VM service to the partner VM. So here there is zero data loss, so there is no downtime, no data loss, right? So what happens in FT is there's a partner VM, right? So that is just what you already may have known, that you have an active VM here and you have a passive VM here, and that is called primary and secondary in VMware. So primary VM and secondary VM. So and they are obviously, secondary is standby secondary VM. Okay, so there's a primary VM and there's a secondary VM here, and that is so what happens is that you create a partner VM on the other host and on the other hypervisor as well, and the primary VM is copying everything with synchronous replication to the secondary VM. So what happens is that if there's a crash of the virtual machine itself that has been configured with fault tolerance, or the whole host goes down, in any case it just simply fails over to its secondary VM, which becomes primary, and it fails over successfully, right? So the thing is that here there is no data loss. So this is truly highly available option. Jasminder says, is the recording on? So I will check it out. Yes, numbers are moving. Yay. Yes, recording is on. Okay, so let us go ahead and try to understand that. Okay, tree size, I need to close that. Okay, so we understand now the difference, hopefully, that high availability triggers when the full host goes down. The virtual machines are actually disrupted. There is no partner of a virtual machine there if you haven't configured fault tolerance. High availability kicks in when the full host goes down, and the virtual machines of this host all have to be restarted on other hosts, right? That's what HA does. So there is a downtime there, and this I should write as well. There is a downtime. There is a downtime, right? So that is the problem with the HA. But obviously, when the host crashes, you at least, if you haven't configured virtual machines with the fault tolerance and the host crashes, then HA can at least restart for you. You're not going to be losing the virtual machines like for hours and hours. It's just the downtime is just that time what the virtual machine takes to restart on the other. That much time the hosts will be or clients will be disconnected, and whenever the machine is started, the clients can connect again, right? Okay, so in chat, Deepshika says if host goes down, all VMs in the host should be configured as FT, right? So fault tolerance, okay, and the rest, or we can enable FT at host level, so all VMs in it will go to secondary. Okay, so that fault tolerance, first of all, consumes a lot of RAM, right? Consumes a lot of CPU, a lot of RAM, and especially a lot of bandwidth. Why bandwidth? Obviously, you're making an exact copy of this primary VM in the secondary VM. Whatever changes are being done here are going to the secondary VM as well. So this means you need a lot of bandwidth as well. So fault tolerance is only available for critical VMs. It is only configured for critical VMs. If every VM is configured that way, then you will need a lot of CPU and RAM, and more important, you need a lot of bandwidth there. So FT is only configured for critical VMs, right? Because it takes a lot of CPU, RAM, bandwidth, you can't afford to have every virtual machine, non-critical virtual machines also having FT. That will not be, it will just simply slow down your network at times or during peak times to unacceptable levels. So FT is only configured for critical VMs. That's important. And it's not on host level, it's on virtual machine level. So FT is configured on VM level, right? Okay, so and then the question is Ramajo says, is primary same as active VM and secondary as passive? Yes, primary is active and secondary is passive. So let me just write that down as well. This is active VM and this is passive or standby VM. Passive / standby VM. Okay, then there are other questions as well, and let me check them out as well. So Raman says, how to categorize critical VMs? Okay, so critical VMs are those, obviously you as an administrator and your boss, and suppose there's a sales department, there's a marketing department, and they say that, okay, marketing department says that, okay, out of our 20 virtual machines, 2 are file servers, very critical, and 3 are SQL servers, very critical. So they do tell you that these are the critical machines. So any machine that has thousands of users connected, first thing, second thing, it's running your company. Because of that, suppose it's a hospital and doctors are sharing their data with other doctors, patient data with other nurses as well. So in that case, you will have to they will tell that, okay, these are our critical machines, so we can afford those machines to be done. Suppose there's a virtual machine with ISOs only on top of them. Suppose there's a virtual machine that is infrequently accessed, not a lot. So in that case, you will categorize them as less critical, those where users are always connected, and you will know if the critical machine goes down that how the reaction of your management will be and how bad the reaction of the end users will be. We will know firsthand it was critical or not. But that's not the best way to know it. Okay, so And Xiang says, what will lost during the downtime of restarting on the other host? So Xiang, the connection to the machine is fully lost. So end users, if they were working anything on the, maybe there were 10 machines on E6i1, right? So all 10 machines, they are just simply disconnected. They can't do anything. So, but they are restarting on the other host. So the end users just have to wait until, other than that, nothing else is lost. That suppose the end users were working on a file and that file has some of the work was not saved, that saved work will be gone as well. So that's a problem with this. So you will have some kind of loss there as well. And okay, thank you. So other than the unsaved work is lost, and then where is HA configured? So where is HA? This is we're about to do. So but HA is configured inside the vCenter. Now in the vCenter, we're gonna go create a cluster, right? And inside the cluster is configured inside data center, right? DC. And inside cluster are all these services of HA, DRS, and you will see now, because first we have to understand what we're doing here, and then we're going to do the slab as well. But they are under the DC or data center. First cluster is created, and then these services are available. So hopefully we understand that what is going on here. So HA, always remember there is a downtime there. HA, when physical servers is gone, its virtual machines need to be restarted on surviving other hosts. That's HA gets triggered when the host is down. If you have configured fault tolerance on some of the virtual machines there, they will fail over right away. All other machines, the elite club or VIP machines, will be failed over, so end users will not see or feel anything, no downtime, no data loss. But those which were not configured with fault tolerance will have to restart to that host. So users who are using those virtual machines will be effectively disconnected. And DRS has nothing to do with full crash or failure. DRS kicks in when the host is still powered on but is slow. If the host is slow in terms of CPU and RAM, then it calculates that, oh, the host number 32 is really fast and less virtual machines are there, so let me just migrate or vMotion these machines to that host number 32. Suppose we have 50 hosts there, right? So that's how the virtual machines are then migrated. So DRS needs the physical host to be powered on. HA and FT kicks in when physical host is actually crashed, or in case of FT, if the active virtual machine or primary VM is crashed, the services are failed over to the secondary VM in that case as well, right? So this is the difference between HA, DRS, and FT, and this is very critical for interview as well, that you should be able to confidently tell the differences between these, and also that well, how to implement them. Obviously that's the next most critical thing. Do you know how to implement that? So if we have talked about that, now our plan is to create a cluster. Let's go to our vCenter and create a cluster, and inside the cluster we will find all these services. All which services? These: HA, DRS, FT, EVC, affinity rules, vSAN. So all these services will be there. You will see the major services HA, DRS, and vSAN will be there. And these are internal services. FT, they're internal to the cluster. FT, EVC, affinity rules are. So, okay, that's the plan, and hopefully we understand that what is the difference between the three major services, right? So what I'm going to do is I'll just take a screenshot of it and I will put it here so you could just understand the differences. Then I'm going to go in detail of HA services. What are the services inside? How many ways high availability offers? Well, high availability, right? And so, well, on your side on OneNote, this diagram should be there. So we're going to go for the first two services, or if possible, if time provided, then the HA, DRS, and affinity rules. We're going to go for these three today. So let's go for, first of all, creating a cluster. So we're going to create a cluster now, and then we're going to go for the rest of the configuration and understand them. Alright, so I'll just go ahead to my remote desktop in my home, and so I'm in my vCenter because I unsuspended it from suspension, so I need to refresh it. It's gonna kick me out, and then I'll need to kick myself in. Wow, what a way to say login. Okay, so I'm just gonna click advanced here and proceed to the username, administrator at vSphere.local, small abc wc, okay, wc shift 123 without shift 123. And yeah, no more samosa parties because we're back to lockdown. So you have to sanitize all your samosas when you eat. Okay. And let's go ahead. So I'm logged in now, and yes, Yang, I have. You can put on WhatsApp if you're in the group. I think you are, I guess. So, okay, guys. Once we are in the vCenter, so first thing we need to create a cluster. So how do we create a cluster? So we create a cluster when we go ahead and try to so first of all, cluster is our data center service. So how many data centers we have? We have TorDC and we have NYDC. So so once we have TorDC and NYDC, so we need to make sure that the both hypervisors are under one data center. The hypervisors have to be under one data center for them to be in the cluster. So cluster cannot span across data centers. Cluster only works under one data center. So we have TorDC and we have NYDC. So what we will do first is we're going to move our hypervisor from NYDC to TorDC. So these two hypervisors should be together under any one data center. So that's our first task here. And then we're going to go for the other one. In class will do. Yeah. Okay. Well, there was one student asking. Okay, so yeah, how do we move the hypervisor from NYDC from NYDC to TorDC? So I'm gonna click on the NYDC ESXi2 hypervisor. I'm gonna click on that. I'm gonna right click on that hypervisor under NYDC. I need to move it under TorDC, right? So when I right click on the hypervisor ESXi2 under NYDC, I'm just gonna go down to move to. There's a move and to, right? So I'm gonna click move to here, and then it will ask that where do you want to move this hypervisor. So I'm just gonna say, can you please move it to TorDC, the other data center, right? So I'm just gonna select that TorDC and press O and K, and then it so I did select O and K, and there's a refresh button here refreshing going on here. So hopefully one day, Monday or Sunday, it's gonna be moved, and it is moved, right? So that's the first thing, and that's the second one. Oh, okay. So there's something going on there on WhatsApp. Well, Orang, I can connect at break time or this, or hope. Well, I wish we were connected on or any other before the class or on weekend. But
I need your help, Amir. Sorry about that. I just removed the host. I want to add them, but it's that I don't know. It asks for privilege folder, something like that. I don't know what
if
the
you see
problem.
this, then you have to go to the E6i1 and simply turn off the lockdown mode on E6i1 and then add it again. So the lockdown mode.
Okay.
So we have a lot of topics. That's why I was saying that before or after the class I can help. But let me just show you quickly where to go. Just go here to this and go F2 here, log in, and oh, okay. I have to put the correct password quickly. And there is a lockdown mode here. So configure lockdown mode, and I have to press enter. So if you want to disable it, just press spacebar here, and it will, this check sign should be unchecked, and then press enter. So then when you try that again, it will let you connect. So that is the, and you have to do it on both hypervisors or whichever is giving that particular error. So
Okay, thank you. Got it. Thank you.
Alright guys, so what we were trying to check here is, first of all, we are moving to we have moved the host to the Tor DC. Now both hosts should be inside the Tor DC, and second thing is that once these hosts are moved to the Tor DC, now we can create a cluster on Tor DC, right? We can create a cluster on Tor DC. So I'm just gonna right click here on Tor DC. There's a new cluster here, and there's a new cluster here on the Tor DC. Once I click the new cluster, it's a pretty simple thing. It simply asks that what is the name you want to give to the cluster. So it could be any name. We can go for Tor cluster. There's a name, Tor cluster, right? Now you can see that it shows that the cluster is offering DRS service and vSphere HA service. HA is high availability, EVC service, which is enhanced vMotion compatibility, and vSAN service. So we're going to talk about all these services obviously, and we don't need to enable any service now because we're going to later do that. So right now, if you put the Tor cluster here, then press O and K. So just give the name, don't select anything, and OK. So once we press OK here, you can see that Tor cluster has been created. So this is a Tor cluster created, and the two hosts are also under the Tor DC, and the cluster is also under the Tor DC. Now the cluster still does not know that there are two hypervisors. So how would it know? When we add this hypervisor to the cluster, then it will know that. So I'm going to right click on this first hypervisor. We can drag and drop these hypervisors into cluster, or better, right click on the hypervisor itself, and there's a move to option. So I'm just gonna move this hypervisor to the Tor cluster, right? So I'll click move to here, and I'll expand the Tor DC or Toronto Data Center, and under that Tor DC I see the Tor cluster. So I'm gonna select that. Please move the first hypervisor to the Tor cluster. I'm gonna press OK and wait for it to happen. And one hypervisor has gone to the Tor cluster. I'm just going to go for the second hypervisor. I'm going to right click here and move to. So I'm just going to click move to here, and where it's going to be under the Tor DC but inside the Tor cluster. So I'm going to select the Tor cluster. So I'm just going to press OK here. So now both hypervisors are inside the cluster. What happens when they are added to the cluster is that the HA service in the cluster automatically sends its agents to the two hypervisors. So I'm just going to expand the Tor cluster here, and you can see when I expand that the two hypervisors are inside the cluster now, right? So the two hypervisors are in the cluster, and now once these two are in the cluster, now we can use all the features there. What features? The DRS, HA, EVC, affinity rule, FT, vSAN, ABC, XYZ. Okay. Once there, the two hypervisors are there. Now I'm going to click the Tor cluster here, right? The Tor cluster. So I've clicked the Tor cluster, and I can see on the right side, getting started, summary, monitor, configure, permissions, hosts, VMs, data store, networks. So a cluster is a group of hosts. When you add a host to a cluster, the host's resources become a part of the cluster's resources. The cluster manages the resources of all hosts within it. Okay, and these are all the services that we already talked about. So if we go to the summary of, if you've selected Tor cluster and then go to the summary, in the summary, obviously it's going to show you the total CPU, which is the total of the two. Suppose you had 200 hypervisors and each had 16 core CPU, so 16 times 200, so it will show you that. Suppose 200 hypervisors and each hypervisor had 1 terabyte RAM, so 200 terabyte RAM. It would show you here collectively for the memory, for the CPU, for the storage. So I have given 44 GB RAM to both hypervisors, so the cluster shows 8 GB RAM, right? So that is what cluster does. It just collectively shows how much total resources are there. So that's the first thing. And second thing is that there's monitor, there's configure. So obviously, just like in Tor DC, we were going to configure as well. So, or hypervisors then configure. So we're going to select Tor cluster, but we're going to spend most of the time in the configure tab here. So I'm just going to click the configure, and then inside the configure tab, you can see vSphere DRS and vSphere availability. Then there is vSAN. So first of all, there's a services here. If I just collapse or open the services here, so you can see that the first the two major services are vSphere DRS and vSphere availability. And then if I just collapse it, then there's vSAN service. If I collapse that too, then there's configuration, the rest of the cluster configuration under configure, and then just the configuration. If I just collapse that, so the three major services are services, vSAN, configuration here. So I'm just going to expand all of those. And so first of all, we see here services, vSphere DRS and availability. If we click any one of them, these two actually work together, right? But you have an option to actually turn off any one of those as well. So first of all, if we go for vSphere availability here, so I'm going to click that vSphere availability, where Tor cluster, configure, and then vSphere availability. So once you select vSphere availability, then on the right side you see edit, and you can also see here vSphere HA is turned off and proactive HA is turned off. So what is vSphere HA? Okay, that's high availability, but then what is proactive HA? So proactive, the word itself says that you have some automated features there that we need to talk about. So vSphere HA is turned off and proactive HA is turned off. I'm just going to click edit now. So once we click at it here, you can see vSphere availability and vSphere DRS. And under vSphere ability, you see a lot of options here. Failures and responses, proactive HA failures and responses, admission control, heartbeat data stores, advanced options, right? So within vSphere availability, you see on the right side, vSphere availability is comprised of vSphere HA and proactive HA. To enable proactive HA, you must also enable DRS on the cluster. So what are those? So first of all, if we select the turn on vSphere HA, so well, this is ready now. Suppose you just turn it on, only this one, then this is ready now to restart the virtual machines from a crashed host to the surviving host, right? So if you turn on this feature, but there are so many advanced features that you need to turn on as well. For that, you need to turn on proactive HA, but I can't do that. So it says that turn on DRS to enable proactive HA as well. So other than that, it's gonna restart the virtual machines of the crashed hypervisor on the powered on hypervisor. This is already enabled, but if you want more advanced features as well, then you need to turn it on. So we will do that now as well. So we're gonna go to DRS, we're gonna turn on the DRS, then we're gonna come back here and turn on proactive HA as well. So let's go to DRS. We're not discussing DRS right now, but we're discussing availability, vSphere availability, and vSphere and proactive HA. Then we're gonna go to DRS later, but we're turning on DRS now. So I'm gonna click the DRS here and simply turn it on, and we're gonna discuss all these options. But first, we're still sticking to vSphere availability or HA, high availability. So I'm going to go back after turning on the DRS. I'm gonna go back to vSphere availability. And in vSphere availability, now you can see that turn on proactive HA is also clickable. So I'm just gonna click that as well. So we have enabled two types, vSphere HA and proactive HA. So overall, these guys just make sure that if the host goes down, it crashes, the virtual machines will be effectively disconnected. There will be a downtime and it will be restarted on the other host. But when they work alongside with DRS, so there are some extra features they get, and also that once you've turned it on, so what are those other features, or what are these options here? So first of all, it says host failure here, restart VMs. So this is what we've been discussing. If the host fails, host is ESXi host or physical server. So if that fails, what do you want HA to do for you? Restart VMs. Exactly what we want is configured here by default. Restart VMs using VM restart priority ordering. Suppose, and priority ordering, that is also very good. You can just also prioritize that. Some critical VMs you want started first, and some non-critical VMs you want started later. So you want non-critical VMs to wait until the critical VMs have started first. So if the non-critical VMs are starting as well as critical, so the CPU and RAM will be divided, and it will take longer for the critical VMs to start. So critical VMs are going to run your company, or maybe they are earning the company millions of dollars, and if they go down, companies might start losing per hour thousands of dollars as well. So some of the VMs or the applications on top of those virtual machines are so important, right? Okay, so that is good. We understand. We were talking about HA. This is its main task. Then what are those all other options? Yeah, proactive HA, I haven't talked about it yet, Ziang. So I'm actually going towards proactive HA. I'm talking about this first option here. Host failure and restart VMs. So that is because of this option, turn on vSphere HA. But what is proactive HA? I will now start talking about it. But proactive basically means that do you want some other automated features enabled or not? We haven't gone through that, so obviously we will be going through them one by one, then you will know what is proactive HA. Okay, so proactive HA here on the second column is written, and that is manual. What does it say? No response because no proactive HA provider is enabled on the cluster. Okay, Xiang, so you can still ask questions. and try to understand, and then put all the screenshots when you're done during the week after following the video. Okay, so here let's we were going for this. So there's no response. So we're going to talk about all these scenarios now, right? So these scenarios are coming on the other side here: failures and responses, proactive HA failures and responses, admission control, heartbeat data stores, advanced options. So and now if I go to the left side here to talk about these options here, so failures and responses, right? So I'm going to click that, failures and responses. And these are those options, which is one is restart VMs and the others are disable, 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 disable. If I go back here, these are those options, restart VMs and then disable, 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 disable. Manual is not showing there because first you have to enable that. So let's understand these options first when we go back to failures and responses. So it says here, failure conditions and responses. You can configure how vSphere HA responds to the failure conditions on this cluster. So there are different scenarios of failure here, right? And it's basically going to ask here, what do you want the cluster to do? What do you want the vSphere availability feature of the cluster to do? If any component of, I'm going to explain what are these disaster scenarios. If any component goes through disaster, then do you want to restart the virtual machines on that hypervisor, or do you want the HA not to do anything, right? Not to do anything means if the virtual machine, if the physical host goes down, it's not gonna restart. So see this, if you go for the top option, there's a disabled return as well. Suppose I do this disabled, what's gonna happen now? The host fails, it crashes, but it will not restart the virtual machines that were on top of the first or second host, whichever crashed, if we put it on disable. So obviously this is a bad idea to put it on disable. We're going to go back to restart VMs for the first option. Please restart my VMs if the host goes down. But what about the other options here? So response for host isolation. Oh, what is isolation? Separation? Separated? So there's a small arrow here as well, right? So if I click that small arrow, so it says allows you to configure the cluster to respond to host network isolation failures. When the host is isolated from the network, do you want HA to restart VMs, shut down and restart VMs? Do you want HA to power off and restart VMs? But what is host network isolation anyway? So let's talk about that. And what happens is that if you have a lot of hosts here, so there are E6i1, E6i2, E6i3, E6i4, 5, 6, 7, 8, 9, 10, right? So you have suppose that many E6i hosts. And second thing is that they are all connected through a switch. Okay, so that's a switch here, and I'm sure everyone knows that. So there's a switch, a Cisco switch there that is connecting all the physical hosts here, right? So that's the first one here, suppose, and then there is a second one here as well. So some hosts are physically connected to an Ethernet cable, and they are connected to this switch. So this port here, and this port here, and this port here. And then some are connected to this port here and this port here, right? Suppose. So we're talking about host isolation now. Host isolate and shut. So now these switches have an uplink as well, and the Cisco gurus among you would know what is uplink. Anyone knows what is an uplink? Anyone knows what's an uplink? You know. Between two Cisco switches, what is uplink? Oh, so Seth says cable connecting two switches. Okay, Gabriel says traffic sent out of the network. Okay, well, it's normally, yeah, it connects the two switches together, and uplink could be also that it's connected to the gateway or the router, and from there it's taking the data outside. So what happens is that suppose there's a problem with the uplink here, right? So if there's a problem with this uplink, it's gone. So now these hosts are not able to communicate with these hosts here. And how do they talk to each other? There's one more thing that need to be understood here, and that is, as soon as you put the hosts in the cluster, they automatically do an election, right? And they automatically do an election, just like the election in US. But if somebody loses, they actually accept that. No, just kidding. Okay, so yeah, here there's an election, and they automatically define a master host and slave hosts as well, right? So why do they do that? First of all, how do they do that? Okay, there's an inbuilt algorithm with which they do election, and automatically they define, hey, since we're all the same looking, we're all the same capacity, so okay, we all select you, and they point to one host there for no particular reason. We're just selecting you because we're all same, so well, we have to have master, right? So okay, slave host here, and but they have internal algorithms with which they select a master host. But what's the job of a slave host, and what's the job of a master host? Slave hosts normally just do one thing. They send an I'm alive packet. I'm alive every second. I'm alive every second. So master host must be gone nuts after 2 or 3 days of the job, and master host should quit the job. But no, that guy is a very patient guy, and that person just takes every host is saying I'm alive, I'm alive, I'm alive, I'm alive. It's a per second heartbeat going on, and master host then knows that okay, all these hosts are in connection with me, and they are telling me, they're reporting to me that they're okay, right? So that's one thing. And master host is connected to who? Yeah.
Sorry, Amir, can I break? And because in here it says the uplink is down, right? And so there is three hosts connect to the one of the switches. There is another two connect to the another switches. But how can the right hand, the two VM in the right hand can send a packet to the master host?
Okay, so
I didn't understand that.
I was explaining that separately. I created that cross too soon. So let's ignore that cross for now, and let's assume they are good right now. And then I should have made the cross later. So yeah, right. Obviously, you're right. If there is no communication, how can they communicate then, right? So let's see. Let's assume that there was a communication going on and there is no disruption between the two switches. Then I was explaining this topic at that time. So good point there. So right now we're assuming the switches are connected, and every host's slave host job is to report to the master host that hey, I'm alive, right? And then this master host is connected to the vCenter, and this master host reports to the vCenter, hey vCenter, I am reporting to you, sir, that all the slave hosts are alive, and I'm in communication with them, so everything's okay, sir. And the vCenter says, okay, General, thank you very much. So, but also there's another way that's going to be discussed later as well, but since we're talking about I am alive here, not only that the slave host report to the master host, they also report to the data store. That's a backup, right? Data store 1, suppose, and there's data store 2, and then data store 2. Let me just so what is this I'm talking about now? First thing we understand, right, that slave host is reporting to the master is reporting to the vCenter, everything's okay. But there's an option that you can select, and that is that the slave host can also report to the data store and they can also send a heartbeat to the data store that I'm alive. You can manually do that. Hey, not only tell the master host, but hey, slave host, also tell the data store, whichever you choose. You can choose all three data stores. You can choose any one data store that not only they should tell the master host, they should also inform the data store, I'm alive, right? So they can report to the data store as well. Now, why this option is there, and this option we understand that master host needs to know every host is good, right? But optionally, you can let the slave host send that same heartbeat to any one of the data stores or all three data stores as well. Why is that? So, what now? Suppose, first of all, there's a network isolation going on, and now we're assuming that we lost that connection between the two switches, right? So this connection is gone now. After understanding that, okay, these two guys are disconnected, right? So when these are disconnected, so they, first of all, what will happen automatically is that these two slave hosts will automatically do an election, and they will form their own master temporarily, and whoever is the slave will start reporting that master. I'm alive, master. I'm alive, master. I'm alive, master. But they both are disconnected to their actual master because of the disconnection here, and one of them becomes master as that's by design, and automatically other ones, suppose there are 150 other hosts connected to these switches, or maybe there are rest of switches here, right? And there are so many hosts, they all choose their own master temporarily, and they start giving that I'm alive, right? Now what happens is that in this situation, they're saying there's a network isolation that happened. Hosts are isolated. vCenter is asking master host, hey master host, what happened to some of the other hosts? And master host says, sorry, I'm not getting reports from, I'm getting reports from suppose 50 hosts, but the other 150 I'm not getting. Suppose the other switch and other switches had connected with 150 hosts, right? So vCenter has no way of knowing now what is the health, what is if these slave hosts are even powered on or not. Two matter here. Ziang, I'm just giving a guess that suppose we have 150 here, right? No, two. Yeah, there are two master, but this master is in no communication with this master. They are not communicating with each other because of this disruption here, right? Yeah. So there can be two masters here, but yeah, when you let me just explain the whole thing, then yeah, there will be, you will understand, right? In the middle of it, we can't understand. I'm still explaining more, right? So here, yes, there are two masters right now, but this master has no communication with this master. This is a temporary master, so I'll just go for temp, T-E-M-P, right? So then what happens here? So first of all, host isolation has occurred. Now in this case, one thing we must understand in this situation, what is the one thing that you need to understand? Now this samosa-like structure is a NIC card, right? NIC, network interface card. Obviously every host has a network interface card. So first thing you should understand is that if the vCenter has no communication with this host, right, and this host, if the vCenter has no communication with these two hosts, that doesn't mean that the virtual machines have all shut down. Suppose there were virtual machines working, right? Virtual machines. Normally what happens is that if you have lost the communication from vCenter, and this communication was going through this first network card of each, the end users may still be connected through another network card, through another set of switches to these virtual machines. So the first point is, if you lost connection, you sitting on vCenter lost connection to these two hosts, that doesn't mean that the end users have also lost connection to the virtual machine. Maybe your connection to these two hosts is frozen, but there are hundreds or thousands of end users that are connected to these virtual machines and they are fine, right? So that's the first thing we need to understand, that normally a physical host has multiple network cards there. One network card is responsible for connecting us to the vCenter. The other network card is responsible for the end users to connect to the virtual machines. So if there's a host isolation, it's not compulsory that the whole host is gone, it is crashed. It may be that your connection to the host is only lost, while the end users are still connecting and using these virtual machines. In that case, what you want vSphere HA not to do, we don't want vSphere HA to restart these machines. Just because I lost connectivity to those two hosts doesn't mean that vSphere should restart these virtual machines. Maybe the end users through other set of network cards are still connected while only my management connection is down, right? So that's the first thing we need to understand, that it's not compulsory that the virtual machines are also down just because I have lost this connectivity. No, maybe I have lost this connectivity, but all end users are still connected and they're working fine, right? So if I show you with this configuration here, that shut down and restart VMs, if host isolation occurs, no, I don't want vSphere HA to shut down and restart my VMs. I want that option disabled. Why? Maybe it's my connection from vCenter to the host is gone, but otherwise end users are connected. If you select this, all end users will be disconnected for no reason, right? So you can wait for those end users to go home at 6 o'clock, 5 o'clock, and then at night when you know nobody's connected, then you can go to the data center and then check it out that what happened, why is your connection from vCenter to the host is down. So keep it disabled in that case. Excuse me, if you want the virtual machines not to be shut down. So hopefully we understand that first situation is that if you also didn't get the tickets, if you don't get hundreds of calls there and hundreds of tickets there, you will know right away that, oh, only my connection is frozen. Otherwise, obviously, there are many monitoring tools that will tell you that only this network card may have some issue, or maybe the cable connecting from this network card has some issue, but other network cards are okay, and virtual machine separate monitoring applications may be telling you that virtual machines are actually fine, right? So host isolation could cause a loss of your connection from vCenter to the hypervisor. That doesn't mean that the virtual machines are also shut down. So if we go back to the option, no, I would not want to shut down those machines. I will investigate that first. In some cases, very few cases, maybe yes, the whole host is frozen. In that case, run to the data center, first confirm that no end users can also connect. Obviously, you'll get a lot of tickets and a lot of calls there. So you will run to the data center, simply, restart the physical host in that rare scenario. It's not rare, but it happens that the whole host just gone frozen. That's it. So anyway, this happens, and you don't touch anything. You don't shut down the host. You don't restart the VMs. You just do it at night when every end user is gone, right? So hopefully we understand this point. Now, when you have resolved this issue and there is again connection restored now, it is again back, the two switches are talking to each other now. So in that case, what happens is this host, when it realizes that, oh, we're connected to our old master here, so it simply becomes the slave host automatically and sends all the reports or log file reports that whatever it has collected when it was master, it sends it to the actual master, and the master then reports to the vCenter, hey, okay, during the that host isolation, all other hosts were reporting to that temporary new master, and now we're back, and that master has become slave as well, and all the communication has gone back to the master as well, right? So in host isolation, all this happens, and then we just need to know that if host isolation occurs, do we want to restart our machines or not? So the correct answer would be, it's better not to. But why are these options then there? Well, maybe those machines are non-critical machines, right? And maybe they actually are frozen. So in that case, you would select the shutdown and restart. And suppose you discover you were able to come to this problem after half an hour. You were busy somewhere else, and for half an hour the whole host was frozen, and somebody could have restarted it and end users would have connected earlier. So it can happen as well. But the thing is that if you have non-critical machines, go for shutdown and restart VMs, or power off and restart VMs. If you have critical VMs, better keep it disabled. So that is the host isolation scenario here, right, that we talked about. So, well, yeah, so if any questions about this, let me know. Otherwise, let's go for the next scenario. Yeah, we've talked about that enough, so I'm just going to go for the next one. So I would just keep it disabled if there were critical machines there, and this is by default. You can see also it is disabled. So this is a response host. I'm just going to click that arrow here. This arrow I expanded, right? So I'm collapsing that arrow now. So the second one is data stored with PDL, and third one is data stored with APD. What is PDL? What is APD? So PDL is permanent device loss, and APD is all paths down. So what are these two, and when do they happen? So what's the background of that? So if we go back to our scenario where, remember that we have a SAN here, software SAN, and these are the actual disks that have been shared over the network. They have been mapped. These LONs have been mapped to hypervisor 1 and hypervisor 2, right? So, okay, let me just grab another diagram here because I have shown this red sign here on both. So I'll just go ahead and start another copy of this and go up to that picture. Okay, so we understand that this is the software SAN, and we have mapped ones there, right? So what happens is that first of all paths down. Okay, PDL. PDL is permanent device loss. Permanent device lost. What is that? And then the second one, they are actually related, APD, but different scenarios obviously. So all paths down. So if the SAN device goes down, I'm just gonna explain that further now. If storage connectivity to SAN device goes down, right? So what are the two? What's the difference? So the first one is that if the device goes down, what does that mean? The device, the SAN device, that disk, actual disk where the data is actually being saved, actually that goes down. What happens? The virtual machines here will be, these virtual machines here, they have their disks on, virtual disks on this data store, and this data store is actually living on top of mapped a LUN, right? Logical unit number. This logical unit number is coming from this actual physical device. Now, if the permanent device loss happens, or the actual device is lost, or maybe it is failing over, maybe if temporarily it's not available on the SAN side, so obviously your virtual machine is simply not going to, all the data operating system is in the virtual disk, right? That virtual disk is not available. So your virtual machine pretty much is, kind of doing nothing or frozen, because the underlying disk, which has the operating system and the software and operating system plus application, everything is not available anymore. So this machine is as good as no machine, right? So end users are connected to that, and they say that, hey, I can't do anything. So what's going on? So if the permanent device loss happens, what do you want to do? Do you want HA to restart this virtual machine automatically if it discovers that PDL has happened on the permanent device loss has happened? Do you want HA to restart your VMs? So why would you want to restart? Suppose your suppose you're busy somewhere else, right? And this has happened. So you want in the background this to restart the machine. Sometimes what happens is that maybe there's a hiccup and the device comes back up after a minute or so, or maybe after a few seconds. So, but the machine is frozen now because of its unavailability, temporary unavailability. Because of that, it has caused the machine to not be available or just froze. So in that case, yes, a restart would have been a good idea for all the virtual machines, but it's up to you. It's up to you. From your experience, you want to decide that. But what happens is that when the device comes back up, maybe the machine will start running again. In most cases, it actually freezes, and in some cases, it actually starts as well as soon as the that physical disk is available back again. So, do you want the HA to restart the virtual machines if permanent device loss happens? So this is the first thing. Second thing is, what is all paths down then? All paths down is also related to software SAN. In that case, if your paths, the connectivity from the data store to the physical disk is down, the paths are down. First of all, do you have two paths? Right? So do you have redundant connectivity to the two disks or not? So one is down, the other one can be up, or suppose both are down, right? So in that case, what do you want to do? Machine might also result in a frozen state because the underlying virtual disk is gone now. It's inaccessible, right? So do you want vSphere availability to restart your machines or not? So by default, the options are disabled. Again, the same logic applies that if they are non-critical machines, set it on restart automatically. If they are critical machines, you better be there to investigate them, and you should have that time, or take out that time to investigate yourself, because you told vSphere HA not to touch your machines. If any of this type of disaster strikes, then you better be here to investigate quickly and decide what to do. Obviously, you will talk to the SAN administrator, whoever is controlling SAN, or if you're controlling SAN, then you will be going to the SAN side and check that what happened, and then try to fix it as soon as possible. You will know right away if the virtual machines are responding or not, and in that case, you might want to restart yourself the virtual machine. So PDL and APD, right? So all paths down or permanent device loss. In both cases, what do you want to do? You want to restart your virtual machines or not, right? So that's the two disaster scenarios that we're talking about. And if we go ahead, so I'll just so it's up to you. If it's non-critical machines, go ahead and restart them. Critical machines, up to you. You still want to restart? Maybe it's a false alarm. Maybe it actually is down for long, and it can restart that as well. Then there is VM monitoring here. Now, VM monitoring is also saying, kind of same thing. What is that same thing? VM monitoring says that if, okay, I will just create another one. So what happens is that if you have a virtual machine, and that virtual machine has an OS and an application, obviously. So when you install an OS and application, it's not when you in a production environment, you will always have an app and an OS, right? So you also must install VMware tools. That goes without saying. It's understood that you have to install VMware tools in all virtual machines, and normally they get automatically installed, or you just make sure that they are installed. So the VMware tools are always installed. That's what we know already. So there is that Tor DC, right, our data center, and then there is that Tor cluster here, right, and then there is that vSphere HA feature here. So HA feature is saying that if your VMware tools can send me I'm Alive packets as well, right? I'm Alive every second. VMware tools can send you packets, can send the HA packets as well. So what if the packets are not received for a certain time, do you want HA to restart your virtual machine? So in case of VMware tools not sending packets, it could be that the machine is frozen. It could also be that the VMware tools itself are corrupted while application and OS is okay, right? Suppose they're okay, but it got corrupted and HA thought, oh, I'm not receiving this, maybe machine is down or it's crashing, restarting or whatever. Let me just restart it myself, right? So do you want HA to actually respond to this and restart the machine if VMware tools stop sending the I'm Alive packets there? So that's what it is showing here. And so if we go back here, so VM monitoring, it can be enabled, but at your own risk. That do you want virtual machine? Maybe if it's a false alarm and you end up restarting the virtual machine, so better investigate first instead of telling HA to restart your machine in case the VMware tool stops sending the I'm Alive packets, right? So if they stop sending, it could be because maybe VMware tools, or actually the frozen machine is frozen. In that case, yes, it would have been a good idea if HA has restarted on your behalf. But if it was a false alarm, then users were disconnected for no reason, right? So it's better you come and investigate that, what happened, remotely connect and try to check it out. And then, so obviously that's what they're paying you for, and you should connect. Otherwise, for non-critical machines, you can even set this one up that VMware tools are sending constant heartbeats. If those heartbeats stop, hey HA, go ahead and restart my virtual machine, right? So that's called VM monitoring. For OS and for application as well, it does that. But you need to create a code. You need to talk to the technical VMware technical support that, hey, I want my application to send heartbeats as well. And if application is not sending heartbeats, I want my HA to restart the whole virtual machine if it comes down to that. So you can actually do some programming and put some code there, create an API there, and so you have to talk to technical support for that. But in both cases, HA restarts the virtual machine for you. You want to do that or you don't want to do that. So that's what it's asking here. And if I were you, I would want to investigate myself for a critical machine and won't let HA restart it. And suppose there's a switch related or cable related error, and because of that all end users are connected fine, but it's not just sending heartbeats, and there was some network error just from this network card to this network card. Other network cards are connecting the end users, but you told it to restart, it will restart. Anything could happen, false alarms could happen as well, right? So these are those scenarios: VM monitoring, APD, PDL, host isolation. We talked about those with diagrams. So hopefully you will be able to tell those with confidence in the job as well, and also you should be able to answer those in final term exam. But better prepare yourself for jobs, because nowadays they're asking a lot of questions about virtual environment. From there you need to migrate machines to the cloud. So obviously this environment on premises also is equally important, the virtual environment. Okay, so that is failures and responses we talked about. Then there is proactive HA failures and responses. This is just talking about proactive. See this? You can configure how proactive HA responds when a provider has notified its health degradation to vCenter, indicating a partial failure of that host. In the event of a partial failure, vCenter can proactively migrate the host running VMs to a healthier host. So what it says in English is that some maintenance, monitoring application, right? Suppose you have a monitoring application. Anyone knows any monitoring application? Anyone knows the name of some very famous monitoring application? There is StarWind there, but there is SolarWind. Oh, StarWind is not monitoring. SolarWind is, sorry. Yeah, I said that wrong. There's a Dude there as well. So there's an application called Dude, and there's OEM. OEM is a monitoring application. T-Mart, okay. So PRTG, okay. Yeah, monitoring. But guys, so we have also large scale application like SCOM. Ever heard of that? System Center Operations Manager from Microsoft. Grafana. There's one more. Okay. And then there is vRealize. That is from VMware. So SCOM is from, it's a one-stop monitoring application from Microsoft, the SCOM, System Center Operations Manager, and then there's vRealize from VMware. These are both expensive applications. In one of the banks, they had this SCOM application, and it was really doing a lot of monitoring on the, other side. It was doing a lot of monitoring, right? On all the banks, all the branches of the banks, huge environment. So vRealize is also a very big application, very expensive, but it also controls, monitors and automates not only VMware environment, but also Microsoft Hyper-V environment, AWS virtual environment, obviously it's all virtual, Azure environment, Google Cloud. So vRealize is a really multi-purpose monitoring application. But then what you said, those applications are also monitoring applications. So now what are we then talking about here? Proactive monitoring. Now those applications and what you said, now these applications can proactively tell HA, hey HA, I can see that CPU is continuously going for, it's been there for last 1 hour or few hours on 89%, and CPU is slowly going upwards of now in last half an hour it has reached 95%. It's not going down at all, and I predict, or proactively I'm telling you that it's gonna reach 99%. Your machines are already slow, but then they will go down. So already the degradation of performance is there, and your machines are about to go down, right? So that is proactive monitoring, and it's actually giving you a forecast that if the pattern is this, it hasn't gone down from 89% in last few hours, and then it has started actually going upwards. 95% is reached, and it's actually still moving. So you better vMotion your machines now. So this is called proactive monitoring. This is the same for RAM as well. Suppose the RAM is also at 95% for long, and then it's predicting that it's going to go actually worse from here. So you better vMotion your machines right now. So that is where it is saying that you can configure how proactive response when a provider has notified. Provider is your monitoring application, notified its health degradation to vCenter. So health degradation is reported, and it actually predicted that it's going to go worse. So you better vMotion the machine now before it's too late. It's better to have the machines still powered on and vMotioned instead of, powered. They will ultimately power off because of the failure, and then they have to restart it. So a partial failure of the host, that in the event of a partial failure, vCenter server can proactively migrate the hosts running VMs to a healthier host. So we get the idea that it can predict and actually take action as well. Do you want it to take action? It's on manual right now. This means it's gonna give recommendations, because machines can just predict and act, right? So if you put it on automated, then it's going to do automatically what you're telling it to do, and virtual machines will be migrated to healthy hosts, and degraded hosts will be entered into quarantine or maintenance mode. So either they will be put on quarantine, which is that particular machine is not going to do anything, or set of machines are all not allowed to connect to over the network. Maintenance mode means that the full host is gone to maintenance mode. If you know, many of you may know from Windows machines that if you restart a Windows machine and press F8, it goes to the safe mode. So this safe mode in Windows, where the drivers are not loaded as well, and you can actually troubleshoot as well. So maintenance mode is just like that. None of the virtual machines can be powered on or can stay powered on when the underlying ESXi host is on maintenance mode, right? So either quarantine is not a maintenance mode, but quarantine just means that you can still not communicate with those machines. although the host is up. But maintenance mode, the host is pretty much kind of down. You're not going to have any communication of the virtual machine. So it's just saying that, hey, you want the host to automatically decide that, or if it's predicted as it's going to have a partial failure, very bad performance there, machines are hardly starting, then do you want it to take the action, or do you want it to give you suggestion and you want to take action? So it's up to you how you want to go for proactive. Now we understand what is this. And remediation just means that there are 3 levels here. Overall, they're saying that do you want balances performance and availability. Then there is balances performance and availability by avoiding, first one is saying by avoiding the usage of partially degraded host as long as virtual machine. So it says that, first one says that, okay, we're gonna still keep on using that host, we're not gonna take immediate action, we're gonna give it until the last when we are really sure that it's, oh man, this is going down, let's go now. And the machines can still technically go, and the host, we're gonna try to give it more choice there, more chance there for the host to still survive. Maybe it comes back. Quarantine mode for moderate, and maintenance mode for severe failure. So it's gonna take action a little earlier and harsher, and maintenance mode for all failures. So this is saying that if there's degradation, I'm just simply going to go maintenance mode. I'm not going to give any chance. If I have a slight suspicion of their degradation of performance, I'm just simply going to go for it. So this is extreme action there, but your critical machines will be actually migrated in this case. So by default, it's okay to keep it on manual and quarantine mode for all failures. Quarantine mode for all failures just means that it's going to let you use the host as technically as possible, and then it's going to be motion when it's sure that it's going down, right? But about to go down. Now disaster can strike right away as well, but this is like predictive, that there's a trend, there's a pattern that it's going down, so then in that case these actions can be taken as well. So then there is admission control. That's very important. Admission control just means that you control how much you admit. Suppose you admit that you ate chocolate, right? So, but you don't keep on admitting you also had Pepsi, you also had Coke. You keep on admitting everything, right? Okay, I'm just kidding. So admission control is that you are doing capacity reservation. Seriously, what is that? So admission control does one thing. Let me just explain that in simple English, because they're going to use a lot of terminology. We're going to go to that too. So what I was talking before as well, what is admission control equals capacity reservation. So in interviews, you need to really be confident talking about that. They would want to know if you know about the concept and how comfortable you are with explaining it. So admission control is part of vSphere HA, or high availability, and it offers capacity reservation. And what does that mean? That means so cluster, that what I was explaining at the start of the class, cluster must have enough capacity on the other host for the VMs of a crashed host, right? For the VMs of a crashed host. So admission control equals capacity reservation. Cluster must have enough capacity on the other host for the VMs of a crashed host, which means what? That already you will stop all the other hosts from using, suppose, 20% of CPU and RAM. Hey, every host in the cluster, listen carefully. From now on, you're not using 20% of the CPU and RAM. If you reach your CPU and RAM capacity of 80%, we're not gonna let you use more than that for CPU and RAM. Why? Because if the other host goes down, the virtual machine still should have at least some of the CPU and RAM available to accommodate the critical machines there if this host goes down. So this host may have 80% of its RAM already for its own virtual machine, but it's not going to use more than 80% because it's just reserving. Maybe disaster does not strike for the next 5 years. For 5 years, you're just using 80% of the capacity of CPU and RAM on your host. And for your virtual machines, anyone goes down, the other one should be able to accommodate the virtual machines of the crashed host, right? So that is admission control. And then admission control has some settings, but this is the main concept here, right? So if they ask in the interview, okay, can you tell me what is admission control? So you should be able to tell it's capacity reservation, and we're saving the capacity of CPU and RAM on all the hosts in order to tolerate the loss of one host. We can tolerate the loss of one host. So for your job interviews, it's mucho importante, right? It's very important. Okay, so if we go back, what is it saying? Host failures cluster tolerates. So how many host failures a cluster can tolerate? And it says 1. Okay, what does that mean? It's pretty simple. It's saying, hey, we are ready to tolerate the loss of one host. Any one host goes down, we are ready already. We are already ready, right? Okay, to tolerate the loss of one host. So that's good. What does that mean? Oh, they already have begun admission control. So if you lose one host, your virtual machines on that host will be restarted on the other host. That's what they're saying. So host failures cluster tolerates is 1. Maximum is 1 less than number of hosts in cluster. So this is it. They can tolerate the loss of one host because you have just 2 hosts here. So suppose the boss said, no, I want to tolerate the loss of 2 hosts. I can't put 2 here, right? I cannot, right? I think you cannot as well. Why? Because we just have total 2 hosts. Well, if you have 330, 300 hosts, you may go for more hosts as well. So that's one thing. Define host failover by capacity. So then it says that there are some options here. Cluster resource percentage. So that's what they are saying right now, that hey, this much CPU and this much RAM, they have already analyzed that. How much of the capacity is being used in your cluster. So they have already realized that, okay, overall we have just 2 virtual machines. I have just 2 virtual machines here, right? So they are just trying to check that, okay, this much, whatever CPU and RAM the 2 virtual machines need right now is what they will put in reservation, right? So they are reserving the capacity here. But what is slot policy then? Slot policy is that if I select the slot policy here, so it says that that vSphere HA will check. Okay, let me just explain that here. Slot policy is that suppose you have 2 virtual machines here and right, 3 virtual machines here, suppose. Now slot policy means that what is the average CPU and RAM that these virtual machines are using. So how much average virtual machines are there on a hypervisor, and what is the average CPU and RAM being used here. So that is called slot policy. What does that mean? So they will know from the average CPU and RAM calculations of a typical hypervisor that this much capacity of CPU and RAM must be reserved in other hosts. So they just try to check that, oh, okay, overall in average we have 3 machines per host, right? Suppose that's the case, or maybe 10 machines per host, maybe 15 machines per host. So an average they take like 8 cores always, and processor cores, and they always are taking like 64 GB RAM, right? Suppose. So they will keep 8 cores. They will tell every host that, hey, my slot policy or slot calculations are that 8 cores and 64 GB RAM overall in average is being used by a set of virtual machines, a group of virtual machines. So I'm gonna tell every host, please reserve that much capacity. Suppose there are 10 hosts. You tell, hey, every host, can you reserve 10% of your CPU and RAM in order to match this 8 cores and 64 GB RAM capacity reservation. So if this host goes down, so virtual machines will be divided among the 10 hypervisors. They were all saving 10% of the CPU and RAM. So one machine here, one machine on the other host, one machine on the other host, one machine. So slot policy overall is that HA just simply analyzes that what is the average CPU and RAM of any one hypervisor in a group of maybe 10 hypervisors or 20 hypervisors or 200 hypervisors. So what is the average CPU and RAM use? And this much capacity should be available across the cluster, right? So this is slot policy. And if you think that you're really advanced user, so you can go for fixed slot policy. You may be that advanced in VMware that you will tell yourself, oh, I know that how much CPU slot size and I know that how much memory is being used. I'm going to define it myself instead of letting the vSphere calculate it and then reserve that much capacity. So you can do that yourself, or you can better let the machines do the calculations and numbering. So the slot policy here says that, and it says that percentage of performance degradation the VMs in the cluster are allowed to tolerate during a failure. 0% raises a warning. So they just say that how much of the virtual machine's bad performance you want to tolerate, and it says that 100% I'm going to tolerate. If it's giving very bad performance, let the administrator come and do something about it. We're just going to keep the machines here and running. So that's slot policy here. Then there is dedicated failover. This is the easiest one. What is the meaning of dedicated failover host? Anyone can tell me what is the meaning of dedicated failover host? Let's see how easy it is. What is the meaning of this option? Anyone knows? Dedicated failover hosts. What does this do? So anyone knows what's the meaning of this? So Safe says you pick one host for failover. Good. Deepshika says to always failover to a dedicated host. Good. Okay. So exactly, you pick one physical host. Suppose you have 10 physical hosts. If I click the plus sign here, so the two hosts, suppose we had 10 hosts, suppose we had 200 hosts here. You actually pick one host there. Hey, from now on, we're not going to put any virtual machines on you. You are sitting there as a standby host. Whenever the other host goes down, then all the virtual machines of that host will actually be started on this host. So you will be the active host. Right now, you're a passive or standby host. So Xiang says, will that cost more? Well, normally either you divide the capacity on all the hosts and use the CPU and RAM of every host. That is a better strategy than keeping one host, full one host. Suppose you purchase in $5,000, maybe you spent $8,000 on that host, right? So when this host is just sitting doing nothing, the higher management might not really like that. Although big companies, they have their strict policies, so yes, it is also okay. Otherwise, let this host also be used, and just don't let them all use the maybe 20% of their CPU and RAM or 10% of CPU and RAM, however the calculation was done. But no, it does not cost more. It's just that it looks like we're wasting $8,000 or $5,000 or $2,000 here. But it's the same thing. Either you distribute the capacity among all the hosts that they're not going to use 20% of their CPU and RAM, or you can dedicate one host here. But normally the management or non-technical management, higher management does not, sometimes they don't like it. Otherwise, they don't care. Also, all they want is the services to work permanently. That's it, all time. So it's the same thing. You would divide that capacity reservation on all hosts, or just dedicate one host for the same capacity reservation. So normally you will see in production environments that they divide the capacity. They use every host. They don't make one host sit forever. Maybe disaster doesn't strike for a year, 2 year, 3 year, right? So it's sitting. Okay, so I'm just gonna cancel out from here, but we understand the purpose of that it is we can actually fully dedicate one host here as well. But the recommended is this, where the default option was this as well, right? So recommended is cluster resource percentage. So let the vSphere HA decide, after doing calculations and taking patterns down in the log files, and check that, okay, overall there were these many virtual machines are there, and this much CPU and RAM they are using on average, and this much I should reserve as a capacity, right? So let the machines decide that. That's better. But otherwise, some advanced administrators, VMware administrators, very genius administrators, they just go for their own calculations because of their vast experience. Otherwise, better let the machines decide that. So I'm going to put it back to cluster resource, where the cluster is saying, hey, we are already meeting, or we're doing some capacity reservation right now, and we can tolerate the loss of one host. By default, it is on that, right? Now, heartbeat data stores. This is what I was talking about before, that you can remember that diagram, what we were talking about in terms of I'm alive packets there, this one. So all slave hosts were sending I'm alive packets to the master host, right? But what if anytime disaster strikes and the slave hosts are not able to communicate with the master host, right? Suppose that happens. So these two hosts, or these 200 hosts on this side, cannot send I'm alive packets to master host. So you would have connected them to one data store as well, right? So, and those data stores are all connected obviously to the vCenter. Master host is connected to the vCenter. The data stores are connected to vCenter as well, right? So what happens is that if the master host somehow is not getting the report, from the other side, the slave hosts are reporting to data store as well, and vCenter can say, hey, data stores on the other side, are you receiving my missing 20 hosts there? Are they all fine? And the data store says, yes, sir, they're all fine. They're sending me the I'm alive package, so don't worry. Yes, they're good. So that's what this option is all about. That you can go ahead and select one of those data stores there, and now the slave hosts will be sending the I'm alive packets to this data store, or one of the data stores, whichever you select as well, right? So that's just for that. You can select all data stores, or you can select one data store, and the packets will start coming there as well, and vCenter will know from there that, okay, we're good, right? So I'll just go for select one here, and then there are advanced options. Advanced options are just for having, you want to change the default behavior of any of these features there. Suppose the default behavior here is that admission control can tolerate the loss of one host. You can just change the default behavior. Hey, it has to be all the time 2 hosts minimum that it can, or you can just change the heartbeats. Okay, the data stores, all of the data stores by default should be receiving heartbeats, and it should not be dependent on our selection. So whatever you want to implement, whatever is implemented already, or the default behavior of DRS and availability, especially HA, so you can put some code there that can let HA be configured other than what it is already doing, right? Okay, save says here, how about if the host lost connectivity to the data store instead of the vSphere? So, well, it's still sending those packets to the master host anyway. So if they suppose there's a PDL happens, or PDL is permanent device loss, and or APD happens, so obviously they were still connecting to master host. But if the master host is somehow they got disconnected from there and they also got disconnected from here, obviously then there is no way to know. vCenter at least will not know, and they will, the log files will say we have disconnected from slave host. So you as an administrator have to go ahead and confirm that yourself by going to the data center and check out yourself then manually what's going on. Are the hosts up? Are the end users are okay? Ping some of the virtual machines there. Are they okay? Check the monitoring applications there, because now you have no way of knowing from the data store side or the master host side that some of the slave hosts are they up or not. Right? Cool. Okay, so well, we get to know about now these advanced options. Normally you have to go to the VMware documentation site and better talk to the technical support and get some code there to write and to change any of the default behavior of the vSphere availability, right? So if we check out all the options there, so failure and responses, proactive HA failures and responses, admission control, heartbeat data stores, and advanced options. So these are the some of the high availability options from the vSphere availability that are offered, and we should be very careful about what we turn on or power on, and it will have direct effect on our productivity and users' connectivity to the virtual machines. If we choose otherwise, we better have a good reason to do that. So we understand then it adds with the experience that you start deciding what configurations should be configured. And sometimes disaster do strike, and from there the administrators learn as well, and they do talk to the vendors as well, the VMware tech support. Hey, I'm about to do that. Will it have any repercussions? So try to read more. But the recommendations are that you're hired for the job. Try not to automate everything and let the vSphere availability restart your machines on every alarm. So better go yourself and check it out in most cases. So we talked about vSphere availability here, and these are the options that it's going to restart the VMs in this case. So the other option is vSphere DRS, right? So with DRS, so now if we understand what does the two options, how are they different? High availability kicks in when there is a host crashed. DRS kicks in when there is a degradation of performance, right? DRS has nothing to do with host crash. DRS only kicks in when there's a degradation of performance. The host is slow, so in that case, so this is the main thing. Host is slow. That's what you need to remember. This is DRS, right? But if host crashes, DRS cannot help us at all. But what does DRS do? If the host is slow, it's gonna migrate the virtual machines to the faster host automatically. It's up to you. You wanna tell DRS to do it automatically, or you can configure that, or you want to simply do it yourself, then let the DRS suggest you only, right? So what happens here is that DRS automation is fully automated already. There's a small arrow here, right? Let's click that arrow and then go ahead. So okay guys, there's 8 o'clock, so let's take a break and then come back and then talk about DRS, and then there's a lab for DRS as well. And let us take that break and then come back. Ready? Okay, so break time. Class starts 8:20 or 8:25. Okay, since you insist. So 8:20. It's already 12 minutes on. Hey, that's not fair. Okay, 8:25. Okay, muting and pausing the video. Okay, so we were talking about DRS, and for DRS, first of all, we were talking about its function, and that is that if the performance degradation occurs, the host is slow, then only DRS kicks in. So what are the levels on which it can actually really kick in itself, or you can keep it manual? So here you have so we have automation level here, and there is manual, there is partially automated, and there is fully automated. So manual is that the DRS simply gives recommendations that, okay, I see that one physical machine, one physical host is slow, so, and I see that that other one is actually faster, so I recommend that please vMotion the virtual machines from the slow host to the faster host. And the partially automated, that's where we get to know one more functionality here. So virtual machines will be automatically placed onto hosts at power on, and vCenter server will suggest migration recommendations for virtual machines. So there are two things that DRS is doing. It's not only migrating powered on machines, but it is also doing placement, automatically placed onto host. What is a placement? So DRS does two things instead of one. One is it automatically migrates the machine, but it also does placement. So if we go for DRS does placement of VMs and migration of VMs. So what's the difference? What is placement? Then we know what is migration, but then what is placement? So placement means that DRS, so that if the VMs have been restarted or are about to start, so they are powered off, or they actually got restarted, right? Or you restarted them. So or about to start, then DRS chooses the best available host for this, for the VMs, and place them on that host, which means, so the virtual machine was running on E6i1, suppose, right? And it got restarted. Maybe the host went down. So now, if it was restarted, in that case, maybe there's E6i3, maybe there's E6i4, E6i5, 6, 7, 8, 10, 20, 30, 200, 300, right? So DRS calculates that, okay, this virtual machine, I've analyzed that it needs 64 GB RAM all the time, minimum at least, and it needs 16 core processor all the time. So let me check E6i2. Oh, right now there are 20 machines there. It's not going to give enough CPU and RAM. Let me check E6i3. No. 4. No. 15, 20, 30. Oh, E6i21. Suppose we have that many E6i hosts there. So suppose this analyzes that E6i21 actually has a lot of CPU and RAM available. So now it's about to restart, or this machine is about to start from shutdown, suppose. So in both cases, in any case, that the DRS will place that virtual machine on the best possible or faster possible hypervisor. So placement just means that if the machine is about to restart or is about to start, then DRS will place it or start it from the best available host according to that virtual machine's requirements. right? So this is called placement. Hopefully we get that. So then the vMotion, the machine is already running and needs to be migrated, right? And placement is machine is restarted or about to start, and then DRS decides that which is the best possible host to start it from, and whatever it was running on before the restart or before the start, whichever host it was running on, DRS will choose the better host than the one it was on. If this is still the best host, it will keep it that way, that okay, the most CPU memory is still available on this one, okay. Otherwise it will go for wherever the best available CPU and memory is, it will start it at. So that is called placement, right? So in that case, it says here, virtual machines, partial automated virtual machines will be automatically placed onto hosts at power on, and vCenter will suggest migration recommendation. So placement it will do automatically, but migration it will still only recommend, it's not going to do it. And fully automated is that virtual machines will automatically place, will be automatically placed onto hosts when powered on, and will be automatically migrated from one host to another host to optimize resource usage. So that is what the fully automated, it just does automatically the placement as well as migration. Both things are done automatically, right? Okay, so migration threshold. Now there is a migration threshold as well. When does the DRS decides to migrate away the virtual machine from a host, right? So that's where they're a bit vague here. They're not very clear that what kind of calculations are decided. These are normally in documentation, you will see that they're internal complex calculations. But if you put that on full aggressive mode, there are 5 levels of aggression here, right? So if you put on fully automated, that virtual machines, DRS will decide which host to migrate to. This is the fully automated level, right? But aggressive, this area means that when does the virtual machine be migrated? At what scenario it should be migrated? So overall scenario is that the host is slow. But how slow is the one that is the host that the DRS should decide to migrate? So it will decide automatically from now on. It's not gonna only give recommendation. This is fully automated here. So if I start from conservative, which is the level 1, apply only priority 1 recommendations. vCenter server will only apply recommendations that must be taken to satisfy cluster restraints like affinity rules and host maintenance. So it says that if it is conservative, this means that DRS will never think of migrating a virtual machine unless the host is actually going down for maintenance or there are cluster restraints there. Affinity rules, we're going to talk about affinity rules as a next coming topic, but right now understand that if the host is actually going down, then it will move. So it's not about the host slow, so it's not going to care about slow host, and it's going to let the machine be there with very slow host if you put it on conservative. So if you go one level up, apply priority 1 and priority 2 recommendations. vCenter server will apply recommendations that promise a significant improvement. Now here I can give you some example numbers because VMware did not give any specific numbers there. But suppose you have one hypervisor that is offering just 20% of CPU and RAM left there, right? It's really slow, or 10% of CPU and RAM is left, and the other host is actually having 80% of CPU and RAM available. So one is very slow, other is very fast. So if there's significant improvement only, then it will migrate. Otherwise DRS will never migrate the virtual machine automatically. If we go to conservative level, between conservative and aggressive, the third level, priority 3 recommendations. vCenter will apply recommendations that promise at least good improvement. Now again, there was a significant improvement, then there is good improvement would be, the percentage would be less. That if the virtual machine, so suppose the first hypervisor shows maybe 40% of CPU and RAM left there, while the other hypervisor shows 60% of CPU and RAM left, so it will then migrate, otherwise it won't migrate. And then it goes up to fourth level, even a moderate improvement. You can just say that 50-50, if it is 50% showing there and maybe 55-60% or 45-40% showing there, then it will go for migration. And the final one is slight improvement. So even if first host is okay, but slightly more, the other host is slightly offering more CPU and RAM, it will migrate at that as well. So this is that's why it's called aggressive, full aggressive. That you have already 60% of CPU and RAM available, but then there is even more RAM available, like 65% more available than the first one. This is slight improvement, and at once VM. So this means that if you put it on fully automated and full aggressive, your machine within 1 hour, 2 hours, maybe it has vMotion onto maybe 5 or 6 hosts already. But vMotioning does not disturb the end users. The main thing is, if you put it on fully automated and aggressive, your virtual machine will always perform the best, unless every host is having very less CPU and RAM. Then DRS has nowhere to go. In that case, only the virtual machine will be going for slower degradation of performance. If any host is left with good CPU and RAM, this machine will be guaranteed to be on that host, which has the best available speed in terms of CPU and RAM. So fully automated and aggressive, this is our configuration. So this is our first screenshot, that the DRS is on fully automated and aggressive. So take your screenshot number 1, DRS on fully automated and aggressive. Take your screenshot number 1, DRS is, and the title is DRS is on fully automated and aggressive. So I'm just gonna take the sample screenshot now for you. So we must have these screenshots there, and DRS is on fully automated and aggressive. So take a screenshot number 1, and I'll just put it on the OneNote. So screenshot 1, DRS is on fully automated and aggressive mode. Okay, and I'll just put those pictures, that picture here as well, and also on WhatsApp, DRS. So screenshot 1 is DRS is on fully automated and aggressive mode. Okay, so once that is done, oh, now I see that message there from hello there. Okay, I guess I was already gone from the seat, then maybe you put that message. Okay, so here if we, so once this is okay, once this is put there, the aggressive is selected, then we can also see some of the predictive DRS there. This is a setting, predictive DRS, that I just went down. So before we go ahead, there's one lab, small lab that we need to do. So make sure that you're fully automated and aggressive here, and I'm going to press OK. So I've just pressed OK on the DRS, right? Which is fully automated and aggressive. So when we have turned on the HA, then the vSphere HA is sending its agents to the hypervisors, right? It's sending its agents to the hypervisors. So configuring vSphere HA, and so once it sets its agents the HA, then it can remotely control its configurations or puts its policies on the hypervisors. Well, it is done for me. It just says recent task completed here, and that's the first thing. And second thing is that if you're on the Tor cluster here, then go to the summary here, Tor cluster, and then go to summary. Now I'll need this machine, my Vmware session, to be full control here, and I need some more space here, right? So the Tor cluster here, and then there is summary. This is the view, right? So in this view, what we need to see is this vSphere DRS. We need to see vSphere DRS. So I'm gonna drag it up, right? And I'm gonna put it up there, vSphere DRS. So that's the first thing I've done here, Tor cluster, summary, and vSphere DRS. Then I'm just gonna expand that, right? So I'm gonna expand that. Now you can see that vSphere DRS, it shows here a green bar, and then there is a balloon that is somewhat in the middle, but it says here imbalanced, right? So this balloon, if it is exactly in the middle, then this means that your environment is fully balanced, which means that every virtual machine has enough CPU and RAM. If it is balloon is to the right side or to the left side, this means that your environment is not balanced. One of the hosts has very less CPU and RAM, and the other one has more CPU and RAM there, and the virtual machines are not really divided in such a way that they have enough CPU and RAM available. So here it says imbalance. So this means that if we had more virtual machines there and we put all the virtual machines on any one host, then it should be fully imbalanced. And then what DRS checks is that if it is imbalanced, DRS's job is to put the balloon in the middle of the bar. So in order to achieve that, DRS every 5 minutes tries to analyze the environment and then take some actions there. If it needs to vMotion a machine, it's going to vMotion. If it needs to place a machine, placement only happens when the virtual machine is restarted or after shutdown it is being started. So then placement happens. So if my machines are both on, then that is then it will be vMotion. So mine says not applicable. Okay, so there is a picture from Omo, and that's the name I am seeing there on WhatsApp. So this is fully balanced. Wow, we should all salute to this one. So this fully balanced means that obviously your environment is perfect. Yeah, if it is saying NA, so obviously it's fully balanced already, and maybe you don't have any virtual machines or machines are shut down, so pretty much no resource is being used at all. So it's just saying, hey, nothing to analyze here because none of the machines are on. So that's where I'm just gonna tell you a lab. So do we all have 4 machines here? I have 2 machines, right? So I'm gonna create 2 more machines here. Why? The objective here is that we're gonna have 4 machines. Suppose you already have 4 machines, that's okay. I have 2 machines, I'm gonna create 2 more. Why? I'm going to put all 4 machines on any one host. I'm gonna try to make this as imbalanced as possible. This balloon must reach on the extreme right or the extreme left, right? And then we will leave it at this. All 4 machines should be powered on, and they should be on any one hypervisor, so we could make it extremely imbalanced. Then what happens? DRS starts doing its magic. After some time, you will see automatically some virtual machines are on one hypervisor and other machines are on the other hypervisor, and the balloon will start coming back to the middle of it. So DRS will do it automatically. Okay, Deepshika says CZN cousin. Oh, okay. Cause you show how you see vSphere DRS. Okay, yeah. Actually, I didn't get it. So, so I'm about to show how to do the imbalance, but can. Oh, okay, that's can. Can you show? Can you show how you see vSphere DRS? Oh, okay. See this torque cluster here and summary. So click the torque cluster first here, then click the summary, and then this vSphere DRS was like this. See this? If I just collapse this now, so it was here. I just went down and dragged it up like this, right? And then I expanded that. Hopefully you got it. So, and Ayudaji says, when I tried moving my 2E6i2 torque cluster, is only giving me the option of NYDC and TORDC. So, are you saying Ayudaji like this? Because you need to expand that. You need to click the arrow here, and then if it's torque cluster, then click the arrow, expand all these, and you will see all those, right? So, well guys, we need to record this video as well. So if you got any issues then with the machines, then we can see at the end of the class as well. But we just need to get this lab done so everyone can follow the video. Those who are not following can follow the video as well. If there is something done in the video, yes, then we can follow, right? So here, now what we need to do is that I'm going to quickly create 2 more machines. If you have 4 machines, what you do is make sure that all 4 machines are on any one hypervisor, right? So if I see my just 2 machines here, VM01, if I click that and go to summary view of that, click the first machine, whichever is there, and click the summary view. So I can see it is on E6i2. If I go for second machine and click its summary view as well, so I can see that the other machine is in E6i1. I'm going to create 2 more machines, make it 4. I'm going to put every machine either on E6i1 or all machines on E6i2. How would I put it? I'm going to vMotion them, right? So let me quickly create. Then I want to see that torque cluster summary view should, so torque cluster here and the summary view here should show me that it's extremely imbalanced. And then you will see the magic that after pretty much half an hour like that, more or less, it will start coming back to, the balloon will start coming back to the middle of the bar, right? Automatically. So we just need to make it extremely imbalanced and let the DRS do its magic after that. If you have put it on automatic, full automatic and full aggressive, right? So we're going to try to make it extremely imbalanced. So I'm just going to quickly create here 2 more virtual machines. Either right click on torque cluster or right click on. If you have 4 machines, you don't have to create 2 machines like I'm doing. I'm just having 2 machines, so I'm just creating 2 more, right? If you already have 4 machines, try to power them on and migrate them to any one hypervisor. Try to power on all 4 machines and migrate them to any other one hypervisor, right? Otherwise, I'm going to show you the whole thing, but let me just create the new virtual machines quickly here. And I'll go for your first name, VM03. If you don't have it, just create with me, just like I'm doing. Just right click on torque cluster, create a new virtual machine, and then what I did is I just gave the virtual machine name here, your first name VM03, then next, and torque cluster is there, compatibility check succeeded, then I click next. There is SRV1, DS1 selected here, click next, E6i 6.5 and later, so click next. And I'm not installing any operating system, so I'm going to keep it 2008 R2. Next. On this page, we have already decided that we're gonna have 1 GB RAM, 1024 MB RAM, 1024 MB, right? So the previous virtual machine we created, this is also 1024, and we're gonna go for thin provision, not thick provision. See this new hard disk? If I expand that, new hard disk here, if I expand that, so there is thick provision already there, so we're just gonna change that to thin provision. For any virtual machine that you create, make sure it is 1024 MB RAM, 1 GB RAM only, and thin provision. So I'm just gonna click next here and finish the first virtual machine. Then I'm gonna create the second. Now because DRS is there, so it would have placed it already to a suitable hypervisor. Later we're gonna change that. I'm just gonna try to power on all the machines and migrate them to any one hypervisor to make it extremely imbalanced. So I'm gonna go for fourth machine here. I'm gonna right click here, go to new virtual machine, and new virtual machine here, create a new virtual machine, next, and there's your first name, VM04, and next. It's also anyone as long as they are LAN-based hypervisors or dev stores. So DS1, 6.5 and later is okay. Windows 2008 R2 is okay. Just make sure that the RAM is 1024. Actually, if you give more RAM, yes, it's going to be also extremely imbalanced, but it may not be balanced then because you're asking too much RAM, which we already don't have. So thin provision for the hard disk and 1024 MB or 1 GB for the memory. And I'm going to click next and finish. So 2 more virtual machines I'm creating here, and I need to power on these machines and then check which hypervisor they are, and I'm gonna put them all on any one hypervisor. You can see that in fact my environment is getting balanced already because DRS, when I'm starting the machine, it's placing them on equally on 2 hypervisors, so the environment would stay balanced, but I don't want that. So what I'm going to try to do is, first I'm going to see that where are the most of the virtual machines, or are they equally divided. So VM04 is on, and the summary view, if I click the machine and the summary view, I see VM04 is on E6i2. Summary view of VM03 shows me that it is on E6i1. Summary view of VM02 shows me that it's on E6i1. Summary view of virtual machine 1 is showing it is on 2. So they are equally distributed among them. So I'm just gonna gather them all up on E6i1. So whichever is on 2, I'm going to migrate them on 1 because I want any one to be having all virtual machines. So I'm just gonna right click on VM01 and I need to migrate. So what I do, I right click on the virtual machine and click the migrate button here. There's a change compute resource only option here, and I'm going to click, keep it selected and click next. Then it should be offering me 2 hypervisors. Okay, good. So my VM01 was on E6i2. I needed to go migrate to E6i1. So it is selected E6i1 and next. Networks is okay, VM network. And schedule vMotion with high priority, yes, do it now. And summary, so go VM1. So while this is moving, I think there's one other virtual machine I have that is on E6i2. I think it's VM04, yes, this one. So I'm just going to right click VM04 and migrate it away to E6i1 as well in order to make a totally imbalanced environment and let the DRS show its magic because it's on full automation and full aggression. So E6i1, yes, that's where I want it to migrate to, from E6i2 to E6i1. Network is okay. Next, schedule vMotion with high priority, yes, do it now, and finito. So now I'm going to finally check that after migration, so VM04 is showing E6i1 in summary view. VM03 is showing on E6i1, VM02 is showing on E6I1, VM01 is showing on E6I1. So this means that if I go to Tor cluster now, because DRS should be in action real soon, so Tor cluster, summary view, and the DRS should be, the vSphere DRS green bar should be imbalanced real soon. But if DRS does its task fast, then you will see that it will be balanced. But if I need to refresh, to check that is it already imbalanced or not. So I'm going to refresh here after putting all the virtual machines on any one hypervisor, and refresh. So far nothing happened, and refresh. After some time, it gets really imbalanced unless the DRS has already started its action. Sometimes it takes a lot longer time for it to show totally imbalanced, or in fact it's going for totally imbalanced instead of imbalanced. That's not fair. Well, that's good, but what I want to show is not there. Really? Didn't move an inch. Oh, okay, it's kind of moving out. Oh, there you go. It's extremely imbalanced now. So guys, the screenshot number 2 is extremely imbalanced. So screenshot number 2 is that whatever, it should be not in the middle of the bar, it should be outside of the bar. That's your screenshot number 2. So try to push it towards outside by doing what I'm doing, and if it's slightly outside, that's good enough, but the balloon should be outside. I'm going to take a quick screenshot here. DRS imbalanced is the title of the screenshot. So first make sure that the balloon is outside your bar here, outside of the middle area, which means that the environment is extremely imbalanced now. So I'll take a screenshot. DRS imbalanced is the title. So your bar must be, DRS bar must be outside the middle area. It should be outside. So I hope it is outside for those who are trying. I have taken a screenshot here, and DRS imbalanced. Keep refreshing. Screenshot 2, DRS imbalanced. Right, so hopefully everyone was able to imbalance. Oh, there are more screenshots. Let me just put the screenshot 2, DRS imbalanced.
Hi. So I
have an observation. When I moved one of the VMs to ESSI1, the other two moved with it. Why did that happen?
The other machine also moved?
Yes, I did not.
I moved only one. I had 3 that I wanted to move to EXSI1. I moved one, and then by the time I checked the other 2, they were also in EXSI1 when I was done.
So either the DRS checks every 5 minutes, and while it was doing its own calculations and movement of machine, it might have happened at the same time when you were doing yours. So
it just moved all of them to EXSI1.
Yeah, so it will only move one when you move one, but if DRS was also in the process of moving its own, putting its own decision, so then it will happen. So try to move them again back to whichever is not on the same hypervisor.
Okay.
And Tor cluster, first name is Taiwan, so I see that it's totally imbalanced, and if I refresh that, it could go try to, so this means that if it is balanced after some time, So DRS would have moved 2 of my machines to the other hypervisor automatically, which I haven't moved, right? I moved every machine to E6i1, but after some time you're going to see if it is balanced, you will see that 2 of the machines will be automatically moved by DRS, and if the environment is balanced, and this is its job. Okay, so save says it moved 1 VM back. Okay, that's good. And we go refresh. So yeah, it does take a bit of time until it is fully balanced. So yeah, we need to make sure that now it's all automatic, so we can just give it time and refresh after some time. Yeah, so the thing is that we can see all of it, and I'm just going to show you one other place where you can actually see that what's going on, or where did the machines moved. So I'm going to show you the monitoring area of Tor cluster and then DRS area here. That's where it shows. But right now I'll just give it a little time until it has done some significant stuff there, instead of just checking again and again, because we can give this time. And okay, total vMotion migration 3. Okay, that's good. So saves machines are already in action. Yeah, but I'm going to show you all that. Where do we need to go and see that? But right now I'm just going to go back to the DRS here. Let's just talk about other features as well and give it time in the background. It's just happening, right? So, and it's Tor cluster and configure. Let's go to Tor cluster.
Sorry, task, I didn't follow very well. Can I ask, after you created 2 new virtual machines, where did you migrate it to?
Yeah, so I migrated them all to E6i1.
Okay, so during the process of create the new virtual machine, so did you specify which hypervisor you're gonna
So
choose?
I just clicked on Tor cluster, but you can simply directly create it on E6i1 as well. So that is also possible. So just right click on E6i1 and go for new virtual machine and then start the wizard. Right?
Yeah. So, do we know where we created the virtual machine on the XI1 or XI2?
So whichever. I mean, like I definitely to the students that you want to create it on E6i1 or 2, or suppose you went for Tor cluster, then it decides itself. It can automatically put it on either E6i1 or E6i2 if you right click from here. So I let that person decide, because I knew that I need to move it anyway to the E6i1 later.
Okay, so we don't care where we going to create the virtual machine.
Yes.
And what's the purpose of you migrate to the EXI1?
Yeah, the purpose of migration was to put all the machines on one hypervisor, so this bar should become imbalanced. So if all the machines are using just one hypervisor, the DRS will say that, hey, this is an imbalanced environment. They are not equally divided among 2 hypervisors. So now you will see that automatically this balloon will come back, because DRS's main job is to balance the whole environment.
Okay, thank you. Yeah, got it.
So I'm going to refresh that since I'm here. If it moved, oh, there you go. So the balloon is way in the middle. So I'm sure now 2 of the machines that I'd never touched have been migrated, should have been migrated by now to the other hypervisor back. So my environment is nearly, getting balanced now. So that's really cool. Now, guys, since we are here, so is this imbalance good? Raman is asking. No, this imbalance is bad. Then the next question would be, then why are we doing that? So this imbalance is really, really, really bad, right? So we're just testing if DRS automation and aggression really works or not. Oh, okay. Which imbalance? Did you show me? Oh, there's a screenshot. Yes, Raman, this is good. What you're showing is good. You're good. Okay. So here, and so here we need to show. Suppose we want to know, right? What happened? Which two machines were migrated back? So where exactly are the written logs there? Is there something in writing that these machines were moved at this time from this hypervisor to that hypervisor? So yes, there is. What we can do is we can click the Tor cluster. I need to know which machines, how did it get balanced back again, right? So it's about to get balanced because it's really near the middle. So I need to know that which machines were moved and is that written in somewhere. So it's in the monitoring area, right? So Tor cluster, and then instead of summary, I'm going to monitor. Tor cluster and monitor. And in the monitor, we see this vSphere DRS, right? Tor cluster, monitor, vSphere DRS. So in the vSphere DRS, when you go there, so you can see the history. So once we click the history, so there are some things written here that there's a placement and there's a migrate written there. So place VM03 on ECX. So whenever you see place, this means that the machine was started or restarted. Then only the word place comes for that machine. So, but migrate, obviously the machine was migrated. So migrate VM04 from ECXi1 to ECXi2. Remember that I moved all the virtual machines to ECXi1, and then migrate VM02 from ECXi1 to ECXi2. So that's where it shows, right? So this page would be our screenshot number 3. Tor cluster, monitor, vSphere DRS, and whatever numbers are written there. Suppose your environment is not balanced yet, or it's not near the balance. Still, come to this area and take your screenshot number 3. Tor cluster, monitor, vSphere DRS. So we can say DRS history. The title of the screenshot number 3 is DRS history. The title of screenshot number 3 is DRS history. So I'm going to take a screenshot now. So title of the screenshot is DRS history. So I'll take a screenshot here. Hopefully everyone's taking a screenshot. And screenshot number 3. DRS history is the title of the screenshot. And I'll put it on the group as well on WhatsApp. Screenshot 3 DRS history. Okay, so we get to see this. Now my environment is pretty much, so what I can see further is that I know that all virtual machines were on ECXi1, but I can now see from the history as well that VM04 and 2 were actually migrated to ECXi2. So I'm just going to go click VM04 and check its summary. So summary view of ECXi VM04 virtual machine 4, yes, it is on 2. I never moved it, so DRS must have moved it. And then virtual machine 2's summary page also shows ESXi2. So now, if these two are there, and I'll check go for VM01, it is on E6i1, VM03 is on E6i1 as well. So the two machines have been migrated to E6i2, and two machines were remaining on E6i1, so that's very good. And so this means that DRS works perfectly. So I'm just going to go for Tor cluster here and go to summary here, and oh, it's kind of actually, it was in the near the middle. Now it's again gone back to somewhat outside, but it's going to try to adjust and check that what's going on. So if there is a difference of RAM allotted to the virtual machines, then also it could do this as well. So suppose the exact same amount of RAM is not there, then also it happens that it can stay on one side. It will try its best to totally balance the whole environment, but sometimes it can't if there's too much RAM given to one machine, right? Okay, so but it will still try to adjust and try to make sure that the environment is balanced. So that's the main thing, but it can go only a certain level given the virtual machine's virtual hardware configuration. So that's DRS, but there were some more options of DRS as well. So if I go back to Tor cluster and then click configure, and in configure there's a D, R, and S. So I'm going to click the DRS and click edit. It just still opens the same window where the vSphere availability and DRS both are there. So you could have gone from vSphere availability and edit instead of DRS. It's the same window. So if I click the vSphere DRS and click the edit button, so when you see that, you can see DRS automation, additional options, power management, advanced options there. So we have already gone through DRS automation. Like if you expand that, so we have talked about this portion here, where it is fully automated and fully aggressive. If you go further down here, so you can see that there is enable predictive DRS. So that's pretty cool. Just like you saw the vSphere proactive, right? So there is DRS predictive as well. And what does it do? In addition to real-time metrics, DRS will respond to forecasted metrics, right? Provided by a big monitoring application called vRealize operations server. So I already mentioned that this is the monitoring application, vRealize. And you must also configure predictive DRS in a version of vRealize operations that supports this feature. So what it's saying is that if you have a very powerful monitoring application, especially if you have vRealize operations separate, it's a separate license, it's pretty expensive. So it can also predict that your hypervisor is about to face degradation of performance, right? So it can predict not only that, when the actual degradation happens, even if it is about to happen, your virtual machine will be migrated, or if there's a placement required, it will be the placement will happen. It will be placed on a proper hypervisor. So that is just predictive. It's just a bit even earlier. It's going to do that. So other than that, what happens is that enable, can perform any DRS activities. I think Deepshika, your one of the hosts has some issue. There's you need to select the host and then click the summary and check that error. And you can put that error, and those who were having issues can talk to me at 10. Or we can just finish this earlier, and then we can also then check our issues of vCenters. Okay.
I think it is saying vSphere HA status. Sorry, just give me one moment. vSphere HA host status is the error.
Like if you click the host and then click the summary page, right?
Yeah.
So in the summary page, the whole message should be there. You can just copy paste that message or take a screenshot of that message and put it here.
Okay.
Okay, so, and yes, I have logged off. Yeah.
Could you please go back to the edit part?
Edit. Oh, like can start from here? Okay, here.
Yes.
DRS and edit.
Okay, under configure. Okay, thank you.
So I'll click the edit here, and so we have DRS automation and then additional options. So if I go to DRS automation here, so we just need to try to understand that what's going on. vSphere HA agent for this host has an error. The vSphere HA agent is not reachable from vCenter, so this host currently has no management network redundancy. Okay, try to restart only the second host.
Yeah, I just did that. I restarted it.
Like refresh, then, because it's gonna take time. Otherwise, if it persists, then you have to take out this host from the door cluster and then put it back again. But that takes time to take out, and then it takes time to put back again inside the. When you put it inside the door cluster, so it installs the agent. When you take it out, it removes the agent of HA at that time. So if it persists, otherwise try to refresh, keep refreshing until the error is gone. But try to go for the DRS. Well, it depends on what you are unable to do. If you have configured DRS, so normally it is automatic.
No, because my all machines are automatically going to the other host. So by default, it shows perfectly balanced because I think vCenter is just considering one host right now.
Oh, so they're all
So,
on one host and it's saying perfectly balanced. Okay.
Yeah.
So the other host, yes, then hopefully this error goes away. Otherwise, normally it goes away when you take it out from door cluster and then put it back again.
Okay.
I'll try to do that.
Okay,
Unlock,
thank you.
The lockdown mode as well. Although even if it is enabled, then it is supposed to still work.
Okay. Thank you.
Where I can check if my machine is automatically migrated by the DRS?
Automatically.
Then
Yeah. So
there.
see this door cluster, and then monitor.
Checks history, right? Okay.
And DRS and history.
Yeah.
Okay, so guys, let's try to cover the rest of the features here. Then I can go for the one-by-one machine remote connection and issues. So I'm gonna go click edit and then try to check it out now. Well, we can discuss the remaining options of DRS at least and cover that topic today. So DRS automation, if I just expand that, you can see the predictive DRS. So it's gonna predict and it's gonna predict the degradation of performance, and it's going to act if you select this option. Otherwise, it's going to be normal, and but if it's not normal already because you already put it on fully automated and full aggressive as well. So, well, it's okay. I mean, like you don't have to do anything then. The virtual machine just keeps vMotioning. If there is more CPU and RAM in any other hypervisor, it's going to just vMotion right away, right? So that's one thing. And second thing is that there is virtual machine automation, enable individual virtual machine automation levels. There is enable, so override for individual virtual machines can be set from VM override. So it's just saying that, do you have any virtual machine that does not want to follow the DRS rules or vSphere availability rules? So if you have any virtual machines that do not want to follow DRS or availability rules, then you can enable this option. Actually, I'm going to show you after we're done with these options, where is the VM override rules, VM override. So yes, you can do that too. I mean, not every virtual machine has to follow what you've configured in DRS and vSphere availability. And then the next option is VM distribution. So for availability, distribute a more even number of virtual machines across hosts. So what does that mean? Now this means that, suppose you select that, So it will try its best to distribute the virtual machines equally among the hosts. Now that is sometimes not happening, because suppose there's two virtual machines. There are two virtual machines, suppose, that have 128 GB RAM requirement. All other virtual machines have 32 GB RAM requirement, suppose. So there are 8 virtual machines, suppose, that have 32 GB RAM requirement, and 2 virtual machines that have 128 GB RAM. That's a lot of RAM, right? So suppose the DRS actually put 2 machines on one hypervisor and put all other 8 virtual machines on the second hypervisor, because they required less RAM, and so all were put there, and 2 machines required a lot of RAM. Only 2 machines were put there on the other hypervisor. So DRS was able to achieve the balanced status again. You can do that too. But suppose if that hypervisor that had 8 virtual machines goes down, crashes, you lost connectivity to 8 virtual machines because they were all gathered up in one hypervisor. So if you select this option for availability, distribute a more even number, so then DRS will think that okay, since I need to distribute them evenly, so even though 8 virtual machines on one hypervisor and 2 on other hypervisor actually balances my environment, but because we don't want to lose all 8 machines or get disconnected from those 8 machines. That could be maybe 5,000 users, that could be 3,000 users disconnected from 8 machines, right? So how about I just still distribute, although I will not achieve the balanced CPU and RAM status, but I need to distribute 5 here and 5 there, because if you select this option, it's going to do that. Then it's not going to really see that if there's balanced environment achieved or not. It's going to see if equal number of hosts, virtual machines are on all the hosts distributed equally. So if one host goes down, it's taking down majority of the virtual machines. It's taking down, whatever number was distributed. So this option is also okay, but whenever performance is, you cannot tolerate less performance, then you don't need to select this option. You're taking a risk that DRS might gather up all the low RAM virtual machine on one host, and if this host goes down, so many users will be disconnected. But you cannot, tolerate less performance of critical machines. So then you can uncheck this option. Otherwise, you have to check this option. And there is load balance based on consumed memory of virtual machines rather than active memory. So active and consumed, what does that mean? So there is active memory, that is given memory, right? So you have given actually this virtual machine here. Okay, that's not a virtual machine, it's a balloon. Okay. Suppose this virtual machine, you have given 64 GB memory here, and this is the given memory, but what it's consuming is maybe 32 GB, So you have so many users here connected, and the application components are open and the files are being saved, but it's actually consuming 32 GB RAM. It's not really consuming 64 GB altogether. So it's saying that, hey, how about DRS? You don't check that, oh, it requires 64 GB RAM. I don't care whether it is actually using this much RAM or not. I'm still going to try to go for the best available hypervisor to put that, because it's 64 GB requirement. Anytime it could reach up to 64. Right now, maybe it is actually using 16 GB, maybe, right? So DRS normally decides whatever is being given. But if you say that no, go for consume memory, then it will say, oh, hey, it's not consuming much. So let me not just keep moving it around to all those hypervisors for best performance, because it's getting best performance here, because it's only consuming very less RAM. So you can decide according to the actual consumption of the CPU and RAM of virtual machines instead of whatever was given to them. So That is interesting option. So load balance based on consumed memory, and then control CPU over commitment in the cluster. So control CPU over commitment means that you can actually overcommit as well. What is overcommitting? You put virtual machine, so this is a physical server, right? And then there's virtual machine on top of that. Now the CPU, you're giving it like 16 core here, that hey, whenever you need, you can go up to use 16 core processor, while you have here a total of 16 core here. Physically you have that much only available, and this one has maybe 8 core available. So how much of overcommitment do you want to allow? That's what it's saying. Why overcommitment is okay? Because again, that what we talked about, that given 16 core and actually consume 16 core, maybe it's consuming only 9 core, right? So, or 8 cores here it's consuming, but it has been given 16 core. So when you overcommit, you put a machine which has given a core of 16, and you already see, oh, it's overcommitting right now. But you also know that normally it happens that they're not consuming up to that. They're always consuming half of it. During peak hours, you should not be tolerating that, but DRS will take care of that. DRS will just move it away, right, then and there. But if you select this option, then you're saying that, hey, keep this machine here because I know it is overcommitment, but it's not actually consuming that much core, so don't keep moving it from one hypervisor to another. If you select this option, it's going to keep it, even if overcommitment is happening, it's going to keep this here on this hypervisor. So it's up to you. It's your experience. You've been handling VMware environment for like so long, so you would know that okay, if they don't actually use up to this, or during peak time, suppose it's 3 p.m., 4 p.m., people are going, some are gone already, so you know that they're not gonna go up to this. So okay, let me enable that option, or schedule it to be enabled during 3 p.m. Actually, there is no scheduler here. Either you enable it or you disable it, right? But if it is happening, then you can just click it that, hey, don't keep moving around because of the given memory, but whatever it's consuming, decide on that. So that said, then if we go further down, there is a power management here as well. What is power management? So power management is that it's going to save your hydro bill. Your company's electricity bill is too much, and your boss is saying, hey, can you do something about these? Suppose you have 200 hypervisors, 200 E6i hosts, right? And they, at night, nobody's using them, so they are consuming a lot of electricity. So the boss says, suppose that, hey, our hydro bill, the electricity bill is too much, so can you just shut them down? Some of the hypervisors at night, nobody's using them. So you can enable this option. What this option does is that you can what? So what this option does is that suppose there were 200 hypervisors here, and the DPM is enabled. This is actually distributed power management. So what it does is it checks that, oh, now none of the users are connected at 11 p.m. here, and so many virtual machines are not using a lot of resources. They are using like 10% of the CPU memory right now. So then it analyzes, DPM analyzes that if I move the virtual machines of these two hypervisors to this, suppose there are 3, 4, 5 more. So if I move these virtual machines which are not being used at all to these other hypervisors, so I can then make these hypervisors empty, and then I can shut down these machines. So it can automatically vMotion the virtual machines to the other hypervisors, and then automatically send the command for shutdown remotely of these hypervisors. Hence, suppose it was able to do that for 200 hypervisors, it was able to do with 50 hypervisors, right? So that's a lot of electricity, or somewhat electricity was saved, right? But in the morning, when the pressure comes back in, all the virtual machines will move to the other hypervisors, but the users start connected in the morning, they're connecting, and DPM automatically analyzes, oh, now we need to go back because its CPU and RAM is getting scarce already here, and degradation is there. So then first of all, it remotely sends the power on commands with VConLAN, right? This VConLAN IPMI ILO here to these shutdown servers, and those servers will power on, and DPM will move the virtual machines automatically, vMotion them back to the hypervisors, right? The only problem with that is that if they decide not to power on, right? So any, you send a remote command and then it does not power on, then what? Then you run and you really, yeah, so Seth says it would be better to schedule that. Yeah, it is better to schedule that, exactly. We used to do patching in when I was in Scotiabank as a contractor, so we used to do patching every second week of the month. So and we were praying that hey, so we are patching or restarting all the servers across the globe, different branches, and we were praying that oh God, please don't let any server just not be stuck on the restart. We were scared for them that after restart, so they are running 24/7, right? 24/7, 365 all year. They are running. Anytime when you restart or shut down, they can, some component can go down. So, well, this can happen here as well. They're also saying that please check for all power on methods, test exit standby for each participating host prior to enabling DPM. So make sure, maybe they are new hosts, and that please test that when you send a remote power on command, they do start smoothly, right? So don't touch a running system. Well, they're all running. In the morning they were running, and in the evening the machine running VM or those hypervisors were being moved. So, well, they were working in a production environment in the morning, and in the evening they were shut down. So if you enable DPM, so there's kind of a risk there that if anyone server decides not to start, then what? So in that case, test it first and then go for it. So Ramajo says, for vMotion, will we consider cold and hot vMotion, or any type of vMotion will take place? Any limitation of DRS for DRS? Normally, it's all powered on. DRS does vMotion for power on virtual machines only. And placement for shutdown, it does not go for powered off. So why powered on? Because it's all about degradation of performance, right? So powered off virtual machines has nothing to do with performance, right? So powered on virtual machine would need better performance. So that's why it's always with powered on virtual machine that DRS deals with. Okay, guys. So here, we must understand that if you're enabling that, did you test your physical servers if they start when you send them the VConLAN or IPMI or ILO from those applications? If you remote tools or monitoring tools, you want to start them, do the start, right? So good luck with that. And but we understand the purpose of that, right? That it's for saving the hydro bill. The main thing is that we rely on that please start in the morning when remote commands are sent to you. So whether to start or not, up to, maybe they're new, they're good. If they're old, don't take the risk. So, and then advanced options there is just for changing the behavior of whatever we discussed here, and you want to change some basic behavior of DPM or DRS, then you can just put some code there. Again, it says advanced options, so it's risky, but you want to do something, then contact the technical support and get the code from them, put it here, and it's going to do what the code tells it to do. So turn on vSphere DRS is there, and we're going to just keep it on. So I'm just going to press O and K here, right? So I did not enable anything. Do not enable DPM. That's the first thing. I did not enable DPM, right? Did I? No, I did not. Even if I did, I will turn it off. Yeah, it's off. So it is off. Now, what about this option, override? Let me just quickly show you the override option here. What is override again? The virtual machines do not have to decide, they do not have to follow whatever DRS tells them, whatever availability tells them. Virtual machines do not have to follow that. And then it's like it's not compulsory that when you enable it, every virtual machine will follow that. So whichever you decide not to follow, you can manually just put an override. So where's that option of override? So on this page, other than putting it on aggressive, I didn't select any other option. We discussed about all that, and hopefully you understood. And I'm going to press O and K. And where is the override option? So on Tor cluster configure, where we are already, we can go down, 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 down. So if you go down, 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 and down, you can see the fourth from the last is VM overrides. So click that, VM overrides. Once you click VM overrides here, there is add button here. So I'm going to click add here in VM overrides. Once you click add, so now the options will come here that will show you well, if it opens today. Okay, I'll click again. There we go. Okay, so this is the green plus button here showing. If I click the green plus button, then you can actually add any virtual machine that you don't want to follow here. So I'm just going to click that, your first name VM02, and I'm going to press OK. So suppose this is a way, well, this is the way you can add any machine or number of machines here, and then automation level, you can go for fully automated, partially automated, manual, and disable as well. So for that particular virtual machine, you can go for disabled instead of the DRS. Keep vMotioning this virtual machine, you can click disable here as well. And VM restart priority, so maybe that you can put lowest, that hey, whenever the host, if the host crashes and you had to restart the critical virtual machines, so you can go to the critical virtual machines and put them on highest priority by adding here. So they will actually follow and they will be given highest priority. And then non-critical virtual machines, you can come here, add them as well, and put lowest priority. So whenever physical host goes down and the machines have to be restarted, then it will follow this priority high or low for the virtual machines. So then critical virtual machines will get more CPU and memory because when they are fully started, then these non-critical virtual machine with lowest priority will be started. So that's so this is, you can just go for all those options that we have talked about already, and you can just change their settings for on the virtual machine level. So we can do that from here. So this is our fourth screenshot, that VM overrides. So this is our fourth screenshot here, VM overrides. Fourth screenshot. Let's take that fourth screenshot here, VM overrides. So I'll take that screenshot here. So fourth screenshot, VM overrides. And screenshot 4 equals VM override. Okay guys, so this is it. You can suspend your machines and upload your screenshots, collect your screenshots and upload it to Blackboard, where I did not put that page up yet, so I'll be going there and doing this now. So collect your hundreds of screenshots there and put it in the document and upload it to the Blackboard. Okay, so this is week 10. I'm creating that upload link now. Please upload VQ10. Okay. So go to week 10, refresh, and on first team viewer ID put first serve basis. Whoever puts, so orange says me. I'll stop.